The night is not quiet. It presses down over the ancient lakeshore like a living thing, blackenous, filled with teeth, wings, insects, cold wind, and the restless movements of animals that can see better than any human ancestor can. Somewhere beyond the reeds, a large cat moves without haste through the darkness. Hyenas call from the open ground. Water shifts against stones. The smell of mud, dung, wet wood, and old blood hangs in the air. For a small group of early humans crouched near the edge of a fading flame. The world does not end at the circle of light, but it certainly changes there. Beyond the fire is the older planet, the one inherited from reptiles and beasts and blind instinct. Inside the glow is something different, faces lit from below, hands held toward warmth, fish bones cracking, wood collapsing into red coals, eyes watching not only the dark but one another. Before we go deeper, take a moment to like the video and subscribe. If this is the kind of history and mystery you enjoy, the scene is not one moment from one known night, because no single night survives so neatly in the archaeological record. It is a reconstruction built from scattered clues, burned stone, charred wood, heated bone, altered teeth of fish, patches of ash that sometimes vanish before archaeologists can even prove they were there. But what survives in the record suggests that fire was never just an object. It was a turning point with heat at its center, and around that heat gathered some of the deepest changes in the human story. It changed what bodies could eat. It changed where families could sleep. It changed the reach of hands, the length of evenings, the danger of cold, and perhaps the shape of thought itself. Long before temples, cities, written names, kings, or the first ploughed fields, there is this more fragile empire, a small orange territory in the night, defended by memory, wood, attention, and need. To understand why fire matters so much, it helps to imagine the world before it becomes ordinary. Today, flame feels almost too familiar. It hides inside engines, switches, stoves, power stations, match heads, lighters, furnaces, and invisible electrical grids. Modern people often meet heat after it has been tamed into convenience, but for early humans, fire is not convenient. It must be found, fed, protected, carried, and understood without books or formulas. It can save a life and destroy a camp. It can keep predators away, yet also announce a group's presence across a dark plain. It can soften tubers, roast meat, cook fish, dry wet wood, warm hands, harden tools, clear landscapes, smoke insects, preserve food, and make night less absolute. But at the beginning, scholars still debate how early humans crossed the boundary from using fire when nature gave it to them to controlling it as a dependable technology. Lightning would have been the first teacher, though not a gentle one. A storm crosses dry grassland. A tree splits under a white strike. Smoke lifts, animals flee, a carcass burns. Seeds crack open. Roots soften in hot earth. The first hominins to approach such places would not need to understand combustion to notice that a burned landscape smells different, tastes different, and attracts different creatures. Natural fires leave behind roasted meat, exposed burrows, dead insects, softened plants, and clear ground where movement becomes easier. Some animals take advantage of fire indirectly. Certain birds have even been observed exploiting flames to flush prey, though the evidence for deliberate spreading remains debated. For human ancestors, however, curiosity and hands create a different future. They can pick up a smoking branch. They can gather glowing wood. They can learn that a coal hidden under ash may sleep longer than an open flame. They can discover that fire is not only an event in the sky, but a thing that can be guarded. This guarding may be one of the great forgotten labours of prehistory. Before fire-making is reliable, a flame is not simply lit and ignored. It is a member of the group in a strange sense, alive only if someone keeps feeding it. It needs dry fuel. It needs shelter from rain. It needs embers covered at the right time and uncovered at the right time. It punishes carelessness. A child can burn a hand. A camp can burn. Smoke can choke. Wet wood can fail. The fire that protects one night may die before morning, and then the group returns to cold, raw food and the dangerous patience of darkness. The evidence remains incomplete, but even this uncertainty reveals something important. The human relationship with fire was probably not born as a single invention. Like a switch being thrown, it was a long apprenticeship. That apprenticeship may stretch far deeper into time than once seemed possible. Archaeologists have found claims of very ancient burned materials at several early sites in Africa and Eurasia, though some of these remain debated because fire leaves confusing traces. A bone can be darkened by minerals, a stone can be reddened by natural heat, charcoal can move through soil, ash can dissolve, a wildfire can pass through a place long after humans have gone. To prove controlled fire, researchers look for patterns repeated burning in the same spot, heated artifacts concentrated around living surfaces, bones and stones altered together, microscopic changes in minerals, and evidence that heat occurred where people were working, eating, or resting. The mystery is not only whether fire existed. Wildfire existed, of course. The mystery is when flame became part of human life, rather than a passing accident of weather. One of the most powerful places in this story lies near the ancient Jordan River corridor, at Gesher Beno Yaakov in present-day Israel, around 780,000 years ago. Early humans lived beside a lake in a landscape of water, plants, animals, and seasonal abundance. The site has yielded astonishing traces: stone tools, plant remains, animal bones, fish remains, and evidence of burning that suggests something far more organized than random wildfire. Tiny pieces of charcoal from this place have become a kind of blackened archive. Under analysis, they can reveal what kinds of wood were burned and how early humans may have selected fuel from their surroundings. Some charcoal points toward driftwood and lakeshore trees, reminding us that fire use was also landscape knowledge. A group that burns wood must understand where wood is found, which wood catches, which wood smokes, which wood lasts, and which wood fails in damp air. Fire does not only require flame, it requires ecological memory. At the same site, another clue sharpens the picture: fish. Not a few symbolic fish, not a casual scatter, but enormous numbers of freshwater fish remains, including teeth that preserve traces of heating. Some researchers interpret this as evidence that early humans were cooking fish at relatively low temperatures, perhaps near hearths that do not always survive as obvious ash circles. The detail is easy to pass over, but it matters deeply. Fish is a rich food. It offers protein and fat, and in some forms nutrients important for growing bodies and brains. If early humans at Gesher Beno Yaakov are cooking fish almost 800,000 years ago, then fire is already tied not merely to warmth or safety, but to the transformation of food. Yet no single site settles the whole human story. Scholars still debate how widespread such behavior was, how often it occurred, and whether it represents a local tradition, a broader ability, or a rare window into practices that usually disappeared without leaving a trace. The link between fire and food has drawn enormous attention because the human body is strange. Compared with other apes, humans have smaller teeth, smaller jaws, weaker chewing muscles, and a digestive system shaped for food that has often been processed before it enters the mouth. Human brains are also expensive organs. They demand a large share of the body's energy. This does not prove that cooking alone made humans human, and no single explanation fully accounts for this transformation. But cooking does something remarkable. It begins digestion outside the body. Heat softens fibers, loosens starches, denatures proteins, kills many parasites and pathogens, and makes some foods easier and safer to eat. A roasted tuber, a cooked fish, or a warmed piece of meat can deliver energy with less chewing and less internal work than a raw equivalent. In evolutionary terms, that difference can matter. Over many generations, small changes in energy flow can become large changes in anatomy, survival, reproduction, and development. Still, the story must be told carefully. It is tempting to imagine one heroic ancestor discovering cooking and instantly unlocking the future brain. Prehistory is rarely so tidy. Food processing may have included pounding, slicing, drying, fermenting, soaking, and sharing, long before cooking became routine. Some researchers have argued that external fermentation may also have helped make foods easier to digest. Adding another layer to the puzzle of how human ancestors extracted more energy from their environments. Fire may not have acted alone. It may have joined a wider set of behaviors: tool use, meat eating, cooperative foraging, social learning, childcare, migration, and changing climates. The power of fire is not that it explains everything by itself. Its power is that once it becomes reliable, it touches nearly everything. It touches fear first. The prehistoric night is not a poetic darkness. It is an ecological condition. Many predators hunt better after sunset. Cold drains strength. Insects swarm. A sleeping body is vulnerable. For small groups without walls, doors, metal weapons, or domestic dogs in the earliest periods, a campfire changes the geometry of danger. It does not make humans invincible, but it creates a boundary that many animals hesitate to cross. Smoke can repel insects. Light can reveal movement. Heat can allow rest in places that would otherwise be too cold or exposed. A group gathered around embers can remain awake longer, watch more carefully, and sleep with a little less terror. That alone would have made fire worth protecting, even before its full nutritional consequences were understood. Then it touches time. Without fire, daylight rules activity with brutal simplicity. When the sun drops, the world narrows. With fire, evening opens. Hands can keep working after dusk. Food can be divided. Tools can be repaired. Children can observe adults more clearly. The old can remain useful as keepers of memory, technique, and warning. Stories may grow in the half-light, though stories themselves leave no fossils. What can be said with more confidence is that fire creates a shared focus. It pulls bodies into a circle. It makes faces visible. It encourages stillness without sleep. It turns night from an interruption into a social space. In that sense, fire does not merely help humans survive the world. It helps create a human world within the larger one. This is why the first section of this story must begin not with the date, but with a glow. Dates matter, and the coming trail will pass through them. Ancient African sites, lakeshores in the Levant, caves in Europe, cold glacial landscapes, Neanderthal hearths, debated traces, and later evidence of deliberate fire-making. But behind every date is the same fragile act. Someone must bring fuel. Someone must know where dry wood remains after rain. Someone must protect the embers. Someone must learn the difference between useful heat and destructive flame. Someone must place food close enough to cook, but not so close that it becomes ash. These are not small skills. They are forms of attention written into daily life. By the time fire becomes a companion of human evolution, it has already crossed an invisible threshold. It is no longer only lightning caught in branches. It is no longer only disaster sweeping through dry grass. It is a portable climate, a predator shield, a cooking surface, a gathering place, a toolmaker's ally, and a memory that can die if neglected. Around it, bodies may change, diets may widen, brains may grow under new energetic possibilities, migrations may push farther into cold and shadow, and the line between animal adaptation and culture becomes harder to draw. The flame at the lakeshore burns low. The last pieces of wood collapse inward, and the coals brighten as air moves through them. A child watches sparks rise and vanish into the dark. An adult turns something in the heat, perhaps fish, perhaps meat, perhaps a root dug from wet soil. No one there knows they're standing at the edge of a transformation that will someday lead to hearths, kilns, metal, engines, cities, and satellites. They know only the immediate truth: warmth is better than cold. Cooked food is easier to eat. Light is better than blindness. And the dark beyond the fire is waiting. From that small circle, the long human story begins to look different, because the ancestors who learned to live with flame are not simply surviving inside nature anymore. They are beginning, slowly and dangerously, to remake the terms of survival itself. Before fire settles into the center of human life, the world is older, colder, and more demanding than the circle of embers allows the mind to remember. The ancestors of humans move through landscapes where every meal is a negotiation with teeth, weather, distance, and digestion. They do not yet possess a dependable hearth that waits at the end of the day. They cannot assume that roots will soften, meat will roast, fish will flake apart, or wet bodies will dry beside heat. The day belongs to searching, and the night belongs to endurance. Their lives are not empty of intelligence or skill, because long before reliable fire there are hands shaping stone, eyes reading tracks, bodies moving through complex habitats, and social groups learning from one another. But without dependable flame, many possibilities remain locked away, present in the landscape but difficult to use. Food is the first boundary. A raw world offers abundance, but not all abundance is available. Leaves may be fibrous, roots may be tough, bitter, poisonous, or locked behind skins and starches that resist digestion. Meat from a carcass may be rich, but it is also dangerous, guarded by predators, filled with parasites, and hard to chew when taken from a large animal. Bone marrow and brain tissue can provide dense energy, but they require tools, timing, and courage, especially when scavenging near the remains of kills made by other animals. Seeds may be nutritious, but small, seasonal, and laborious. Tubers may hide underground, demanding digging sticks and knowledge of place. Fruits may come in sudden waves and then vanish. Nothing about this world is simple. It is not a supermarket without shelves. It is a landscape where energy is everywhere and yet difficult to capture. The bodies of early hominins are built inside this pressure. Before the full emergence of the human form, Earlier relatives show a mosaic of traits, some ape-like, some increasingly human. They walk upright, but not all in the same way. They use hands for gathering and manipulation. Their teeth, jaws, and chewing muscles reflect the demands of food that often requires serious mechanical work before swallowing. For many primates, chewing is not a brief act before a meal. It is a large part of the day. Modern great apes can spend long hours processing raw plant foods with their teeth and gut. Early humans and their relatives do not simply escape this burden overnight. They inherit it, modify it, and gradually find ways around it through tools, social cooperation, and eventually heat. But before cooked food becomes a regular option, the mouth and stomach remain battlegrounds where evolution must pay the cost of dinner. This is one reason raw food matters so deeply in the fire story. A raw diet can sustain life, but it imposes limits. Raw meat is elastic and resistant. Raw tubers can be dense and chemically defended. Raw grains and seeds may pass through the body without releasing all their energy. Some foods become far more valuable only after heat breaks down cell walls, gelatinizes starch, denatures proteins, or reduces toxins. Without cooking, early humans must spend more time chewing, more time digesting, and more effort extracting usable calories. The evidence remains incomplete because no ancient stomach contents can tell the whole story across millions of years. Yet the anatomical trend is striking. Over time, the lineage leading to humans develops smaller teeth and jaws compared with what might be expected for a large-bodied ape, relying mainly on tough raw foods. Something is changing in how food is obtained and processed. Fire may eventually become one of the most powerful parts of that change, but the path begins earlier, with stones, pounding, cutting, sharing, and careful selection. Even before controlled flame, tools are already altering the menu. Sharp stone flakes can slice hide, cut meat from bone, open tendons, scrape plant material, and give small hominins access to foods their teeth alone cannot easily handle. A stone tool is a kind of external tooth, sharper and replaceable. Hammerstones crack bones and open marrow chambers that predators may leave behind. This matters because marrow is not just food. It is concentrated energy hidden inside the skeletons of other animals. A lesser-known detail of early survival is how much intelligence may have been required not only to hunt, but to scavenge well. A carcass on an open plain is not a gift. It is a temporary opportunity surrounded by competition. Vultures, hyenas, lions, saber-toothed cats, and other scavengers are part of the same economy. Early humans must arrive at the right moment, know what can be taken quickly, and leave before the balance of risk turns against them. Without fire, nights remain especially hard. The body cools, wounds ache, infants and the elderly become more vulnerable. Damp ground draws heat away. Insects feed without mercy. Predators move through darkness with senses tuned by millions of years of hunting. A group can sleep in trees, caves, thickets, or protected places, but each choice has costs. Trees may protect from some ground predators while exposing bodies to falls, snakes, cold wind, or competition with other animals. Caves can shelter, but caves are not automatically safe. Many are used by carnivores, and the deep dark of a cave without fire is not a home but a risk. Open ground offers visibility in daylight, then becomes a field of uncertainty after sunset. The ability to create or preserve light does not merely make life more comfortable. It changes the kinds of places where a group can rest. Cold is another boundary. The human lineage begins in Africa, but Africa itself is not one simple climate. It contains forests, savannas, highlands, wetlands, deserts, coasts, volcanic landscapes, and seasonal extremes. Nights can be cold even in warm regions, especially in open country or at altitude. Rain can turn mild air dangerous. Wind can strip heat from exposed skin. Later, as humans and their close relatives move into Eurasia, cold becomes an even more severe test. But even before those wider movements, the lack of reliable warmth shapes daily choices. A species without fur, or with reduced body hair over time, must solve the thermal problem through behavior, shelter, clothing much later in the record, and eventually fire. Scholars still debate exactly when reduced body hair became a defining human trait, and it cannot be tied neatly to a single campfire. Still, the broader point remains. Bodies that depend more on culture and cooperation become increasingly exposed to the failure of those supports. The absence of fire also limits the night as a social world. Groups can still communicate, groom, sleep close, and maintain bonds. Social life does not begin with the hearth, but without light, the evening narrows. The last usable hours of daylight matter intensely. Stonework is harder in darkness. Food sharing becomes less visible. Teaching becomes more difficult when hands cannot easily be seen. The faces of companions disappear. A group can remain together by sound and touch, but the visual richness of social life fades. Later, fire will stretch the day and create a glowing center where memory, instruction, and attention can gather. Before that, darkness is not merely an absence, it is a schedule imposed by the sun. There is also the problem of safety in food. Raw meat and fish decay quickly, especially in warm climates. Parasites and bacteria are invisible enemies. Early humans do not understand microbes, but natural selection does not require understanding. Groups that avoid spoiled food, process meat quickly, share fresh kills, dry foods in sun, or later smoke and cook them gain advantages. Some researchers have suggested that before cooking becomes routine, other forms of processing may have helped bridge the gap. Fermentation is one intriguing possibility. Foods left under certain conditions can become chemically altered by microbes, sometimes easier to digest, sometimes safer, sometimes more dangerous. The idea that external fermentation could have contributed to early dietary shifts remains debated, but it is useful because it prevents the story from becoming too simple. Fire is powerful, but it enters a world where human ancestors are already experimenting with ways to make food more usable. In this older world, intelligence is practical before it is symbolic. It lives in root memory, in recognizing edible plants, in knowing when animals migrate, in reading weather, in understanding which stones break well, in noticing where water remains during dry seasons. It lives in watching others. A young hominin learns not from lectures, but from repeated attention which roots are dug, which fruits are ignored, which carcass parts are worth the risk, which shelters are used after storms. These are not lesser forms of knowledge. They are the groundwork on which later human culture is built. Fire will add power to this knowledge, but it does not replace it. A flame in the hands of a careless group is only danger. A flame in the hands of a group that already knows its landscape becomes transformation. The world before reliable fire, then, is not a world before humanity in any simple sense. It is a world in which the ingredients of humanity are already present but constrained. There are tools, social bonds, movement, memory, opportunism, and adaptation. There is hunger, fear, and ingenuity. There are bodies seeking more energy than raw landscapes easily surrender. There are nights that shut down activity, climates that punish exposure, foods that resist digestion, and predators that make darkness a second wilderness. When fire finally begins to enter this world as something more dependable than lightning, it does not create intelligence from nothing. It gives intelligence a new medium. It lets knowledge burn, glow, and travel. It takes the old struggle for food, warmth, and safety and changes the rules slowly enough that no single generation may understand what has begun, but deeply enough that the descendants of those fire watchers will inherit bodies, habits, and possibilities shaped by heat. The moment fire becomes central to the human story, it also becomes difficult to see. Stone tools can survive for hundreds of thousands, even millions of years, because stone does not easily forget. Bones may crack, weather, mineralize, scatter, or disappear. But under the right conditions, they can still hold shape long after the flesh is gone. Teeth endure with stubborn clarity. Shells, pigments, cut marks, and sediment layers can remain as fragments of ancient behavior. Fire is different. It is both powerful and strangely shy in the record. It consumes its own evidence. It turns wood into ash, ash into powder, powder into chemistry, and chemistry into a faint stain that may later be washed, trampled, burrowed through, dissolved, or mistaken for something else. The technology that may have changed human evolution leaves behind some of the most fragile clues. This is why the question of early fire is never as simple as finding something black in the ground. Blackened material can deceive. A bone may appear burned because minerals have stained it. A stone may redden because of heat, but the heat may come from a natural wildfire long after humans have abandoned the place. Charcoal can be moved by water, roots, insects, or later human disturbance. Ash can vanish in alkaline or acidic soils. Sediments can slump. Cave floors can be reused by animals and people across thousands of years until one surface blends into another. Even a real ancient fire can leave only a ghost, a patch of altered sediment, a concentration of heated stones, a cluster of bones changed by temperature, a microscopic signal invisible to the eye. Archaeologists searching for early fire are often not looking for a fireplace in the modern sense. They're looking for the memory of heat. The problem begins with the difference between fire in the environment and fire under control. Wildfires are ancient beyond humanity. Lightning ignites vegetation. Volcanic landscapes burn. Dry seasons turn grasslands into fuel. A natural fire can sweep across a campsite before or after people occupy it, leaving burned stones and bones in the same general layer as human tools. That does not automatically mean people sat beside a hearth. To argue for controlled fire, researchers need context. They ask whether burned material is concentrated in small areas rather than spread widely. They examine whether heated objects lie on a living floor where people made tools or processed food. They study whether the pattern repeats over time. They look for evidence that fire was brought into shelters, caves, or protected spaces where wildfire is less likely. They compare temperatures, minerals, microscopic ash crystals, and the arrangement of artifacts. No single clue is always enough. What matters is the pattern. This makes some of the oldest fire claims both fascinating and contested. At sites in Africa, Eurasia, and the Near East, researchers have proposed evidence for fire use reaching far back into the Lower Paleolithic. Wonderwork Cave in South Africa is often discussed because burned bone and plant ash appear deep inside a cave, where natural wildfire is much harder to explain than on an open surface. Other locations have produced heated stones, reddened sediments, or burned artifacts that suggest early human interaction with fire. Yet the evidence remains incomplete, and scholars still debate how to distinguish occasional fire use from regular, controlled, culturally transmitted behavior. A group may exploit a wildfire without knowing how to maintain a flame. Another may preserve embers without being able to create fire from scratch. A third may use fire often in ways that leave almost nothing behind. The archaeological record turns a continuous human learning process into scattered, uneven points of light. Open-air sites create special difficulties. A lakeshore, riverbank, or grassland camp may preserve tools and bones beautifully under sudden burial, but fire traces can be easily rearranged. Water can carry charcoal from elsewhere. Wind can spread ash. Animals can trample sediments. Later fires can burn older surfaces. Roots can pull material downward. When archaeologists encounter burned remains in such places, they must ask whether the fire belonged to the human occupation or simply passed through the same landscape. The ancient world was not a museum with sealed glass cases. It was wet, dry, frozen, flooded, rooted, burrowed, cracked, and walked over by creatures that had no concern for future interpretation. The fire record is therefore not only about what humans did, it is also about what Earth allowed to survive. This is what makes a place like Gesher Beno Yaakov so important. At a lakeside setting roughly 780,000 years old, the evidence does not rely on a single dramatic hearth preserved like a campfire photograph. Instead, it emerges from many small signals: burned flint, charred plant remains, concentrations of material, and traces that suggest repeated fire-related activity. The site has yielded tiny fragments of charcoal that can be studied to identify types of wood, revealing that early humans were not simply burning whatever happened to lie at their feet in a careless blaze. Some of the wood appears connected to wetland and lakeshore environments, including driftwood and local trees. That detail matters because fuel choice is behavior. It suggests attention to the landscape, selection, and perhaps repeated practice. Fire here is not just heat. It is knowledge organized around a lake. The fish remains from the same broad context add another layer of difficulty and possibility. More than ordinary burning, researchers have examined microscopic and chemical changes in fish teeth, especially pharyngeal teeth, to understand whether they were exposed to heat. Some appear consistent with low-temperature heating rather than direct incineration, which has been interpreted as possible cooking. The idea is striking. Early humans at a lakeshore processing and cooking freshwater fish hundreds of thousands of years before many once imagined cooking to be common. Yet even here, caution is essential. Archaeology does not hand over a neat scene of people turning fish above coals. It offers altered remains, spatial patterns, experimental comparisons, and probabilities. What survives in the record suggests a powerful case, but the reconstruction still depends on interpretation. Ancient fire is often proven not by one spectacular object, but by the convergence of many modest clues. Caves can preserve fire traces differently, but they bring their own puzzles. A hearth inside a cave may seem more obvious than burned material in open country, because natural wildfire rarely penetrates deep underground. But caves are complicated archives. They can be occupied by humans, hyenas, bears, birds, and later humans over long spans. Smoke blackens ceilings. Sediments build slowly. Water drips minerals over surfaces. Older layers may be disturbed by digging, trampling, or collapse. A cave hearth can be clear when it is recent and intact, but over tens or hundreds of thousands of years it can become compressed into a thin dark line or broken into scattered flecks. Researchers may use micromorphology, cutting blocks of sediment and studying them under microscopes, to detect ash, burned bone, heated minerals, and trampled surfaces. In this way, the ancient hearth becomes not a visible fireplace but a microscopic landscape. One of the central distinctions in this story is between using fire and making fire. The two are not the same. A group that can preserve embers from a natural blaze has crossed a major threshold, but it still depends on luck, weather, and careful maintenance. A group that can create fire at will has crossed another threshold entirely. Fire-making changes reliability. It allows flame to travel into damp seasons, colder regions, and places where lightning fires are rare. But evidence for fire-making is even harder to find than evidence for fire use. The tools involved may be simple, perishable, or easily misunderstood. Wooden fire drills decay. Striker-light stones may look ordinary unless where patterns or residues survive. Pyrite and flint can produce sparks, but a small piece of pyrite in an archaeological layer does not automatically prove fire-making. Context again becomes everything. This is why later evidence from places such as Barnham in Suffolk draws attention. At around 400,000 years ago, traces of hearths and small pieces of pyrite have been interpreted by some researchers as possible evidence for deliberate fire-making, perhaps by striking pyrite against flint. If correct, it would suggest that ancient humans in northern Europe were not merely keeping flames alive when nature provided them, but producing sparks through practiced technique. Yet the identity of the humans involved remains uncertain, and the interpretation requires care. The site belongs to a world of changing climates and human populations before modern humans dominate the landscape. It may involve ancestors or relatives whose exact place in the human family tree is still debated. What matters for the fire story is not only the excitement of an early date, but the broader lesson the deeper archaeologists look. The more they must separate visible drama from durable evidence. Fire also has a strange relationship with absence. In some periods and regions where researchers expect fire to be common, the evidence appears patchy. This does not necessarily mean people lacked fire. It may mean they used it in places that did not preserve well, burned fuel that left little charcoal, cleaned their hearths, occupied open surfaces later destroyed by erosion, or relied on forms of heat that left minimal traces. But absence can also be meaningful. If a cold region site shows no convincing fire evidence despite excellent preservation, archaeologists must consider whether the inhabitants were truly living without frequent fire, or whether fire use was seasonal, rare, or organized differently than expected. No single explanation fully accounts for the uneven record. The story of early fire is therefore a story of both presence and silence. The archaeological problem of flame forces a humbling conclusion. Fire may have been one of the most important technologies in human evolution, yet it is not one of the easiest to document. It flickers in and out of the record. It appears in charcoal specks, heated stones, burned bones, reddened sediments, altered fish teeth, cave ash, and disputed traces that can take years of analysis to understand. It asks researchers to combine chemistry, geology, experimental burning, microscopic sediment study, spatial mapping, and evolutionary theory. It resists simple timelines, and perhaps that is fitting. fire itself is never stable. It is process, not object. It lives by transformation. It changes everything it touches, then disappears into what it has changed. To follow it through deep time, archaeologists must learn to read what is left after heat has done its work and the night has closed again over the ashes. Control begins before invention. Long before a hand strikes stone against mineral and expects sparks, before dry tinder is gathered with confidence, before a hearth becomes a place that can be remade wherever people stop, there is a more fragile relationship with flame. Early humans do not first conquer fire as a finished technology. They approach it as a dangerous opportunity. A lightning-struck tree burns at the edge of a dry woodland. Grassland fire leaves smoking branches in its path. A fallen trunk glows under ash after the flames have moved on. To most animals, these are events to avoid, or at most to exploit briefly from a distance. To a creature with hands, memory, and social learning, they become invitations. The first step toward control may not be making fire. It may be daring to stay near it. That staying requires a different kind of courage from hunting or scavenging. Fire is not alive, but it behaves with a terrible imitation of life. It eats, it spreads, it weakens when starved and grows when fed. It breathes with the wind. It hides inside wood and ash, then returns when air reaches the ember. It gives warmth while threatening skin. It keeps predators away while creating smoke that can blind and choke. A group that learns fire must learn restraint as much as boldness. Too little fuel and the flame dies. Too much fuel and the camp becomes dangerous. Wet branches smolder. Resinous wood leaps. Dry grass betrays the careless. The earliest fire users may have learned these lessons not through one brilliant discovery, but through burns, failures, accidents, and the slow accumulation of practical memory. The difference between finding fire and keeping fire is enormous. Natural flame is unreliable. Lightning does not strike on command. Wildfires follow seasons, droughts, storms, and vegetation. A group that depends only on fresh natural fire must live with uncertainty. But if an ember can be carried, hidden, sheltered, and revived, fire begins to detach from the event that created it. It becomes mobile, a glowing coal wrapped in bark, carried in fungus, protected in a bundle of slow-burning plant fiber, or preserved under ash may allow a group to move heat from one place to another. Direct evidence for such ancient ember carrying is almost impossible to recover, because the materials would decay, and the act itself leaves little trace. Yet ethnographic knowledge and later human practices show that keeping fire alive can be a sophisticated skill. What survives in the record suggests controlled burning in some ancient places, but the daily techniques that made control possible are mostly gone. A hearth is not simply a fire on the ground. It is a decision about place. A hearth means choosing a surface where flames can be contained, where smoke can escape or be tolerated, where people can gather without constant danger, where food can be placed near heat, where embers can be protected from wind and rain. It may involve stones arranged not as decoration but as control. It may involve clearing dry litter from the surrounding area. It may involve using old ash as insulation, banking coals so they survive through the night, or moving burning material from an exposed place into shelter. A hearth is a small architecture of survival, often so simple that later eyes might miss it. To those who built and tended it, it was the difference between a passing blaze and a dependable center. This gradual control would have changed social roles. Someone had to watch the fire, Someone had to gather fuel. Someone had to understand when a branch was ready, when smoke meant failure, when ash still concealed life, when rain was coming, when dry wood needed to be stored. Children near fire would learn boundaries early, not through abstract rules, but through heat on the skin and repeated warning. Older individuals, even those less able to range far across the landscape, may have held valuable knowledge about fuel, weather, ember preservation, and cooking. In a world where physical strength mattered, fire may have increased the value of memory. A person who knew how to keep embers alive through a wet night carried a kind of power that did not look like force, but would shape whether the group woke to warmth or cold. Fuel choice becomes part of this story in a surprisingly intimate way. Wood is not just wood. Some burns hot and quickly, some smokes heavily, some throws sparks, some holds coals, some is too wet and less dried. Some is useful for brief flames, some for long heat, some for smoking insects or meat, some for cooking more gently. At lakeshores and river margins, driftwood may be abundant but waterlogged. In open grasslands, dung can become fuel when wood is scarce. In colder regions, dead branches buried under snow may be precious. At ancient Gesher Benot Yaakov, charcoal evidence suggests that early humans burned a variety of woods from the local environment, including trees associated with wetland and lakeshore settings. This is a small detail with large implications. Fire control requires not only a flame but a map of fuel in the mind. The control of fire also depends on rhythm. Morning embers may be coaxed back to life. Daytime flames may be allowed to fall into coals for cooking. Evening fires may be built larger for warmth and protection. Overnight fires may be banked under ash. During movement, embers may be carried or left to die depending on the distance, weather, and confidence of rekindling. Such rhythms are not easily visible in archaeology. A site may preserve only the final burned patch, not the hours of tending that made it possible. The evidence remains incomplete, and scholars still debate how often early humans maintained fire continuously rather than using it episodically. But the concept of rhythm matters because dependable fire is not a single action, it is repeated attention. The shift from using natural flame to making flame at will is another threshold, and perhaps it came unevenly. Some groups may have carried embers for long periods before they could reliably produce sparks. Others may have known techniques that worked only under ideal conditions, with dry tinder and the right materials. Fire making by friction demands suitable wood, preparation, patience, and bodily skill. Fire making by percussion requires stones or minerals that produce sparks, such as flint and pyrite, along with tinder fine enough to catch them. These are not obvious procedures. They must be learned, practiced, and transmitted. A person can hold flint for a lifetime and never discover the right angle, the right mineral, the right tinder, or the right motion unless experimentation or teaching reveals it. This is why possible early evidence of fire making is so significant. When archaeologists find hearths together with materials such as pyrite in very ancient contexts, the possibility arises that people were producing sparks deliberately. But caution remains essential. A mineral can arrive at a site for other reasons. It can be collected for appearance, accidentally transported with stone, or deposited naturally. To interpret it as part of fire making, researchers need patterns of wear, association with hearths, suitable toolkits, and a context that makes sense. Even then, no ancient spark is preserved in flight. What remains is the possibility of a gesture, one hard surface striking another, A brief flash, a thread of smoke in tinder, a breath, and then flame. Once that gesture becomes reliable, fire changes status. It no longer depends completely on storms, drought, or a coal carried from yesterday. It can be summoned, though never casually. This does not mean every group everywhere suddenly makes fire easily. Knowledge can be lost, materials can be absent, wet weather can defeat skill. Small bands under pressure may fail to maintain traditions, but in the long arc of human evolution, the ability to create flame opens landscapes that were once far more difficult. Cold mornings become less final. Damp shelters become more usable. Long journeys become less dependent on finding an existing blaze. The group carries not only embers, but a method. Yet even with fire-making, control remains imperfect. Ancient humans are not modern engineers standing above nature. They are participants in a force they can guide, but not fully command. Fires escape. Smoke irritates lungs. Fuel gathering costs time. Hearths leave scent. A flame can attract attention from other humans as well as repel animals. The relationship is always a bargain. Fire offers power in exchange for labor and risk. This may be one reason it becomes so deeply human. It is not a passive tool. It demands cooperation. It rewards planning. It punishes neglect. It turns knowledge into warmth only when knowledge is shared and repeated. By the time humans learn to carry, preserve, and eventually create fire, the old darkness has not disappeared, but it has been pushed back. A storm may still drown the embers. A careless movement may still burn skin. A cold wind may still test the group through the night. But now the ancestors possess something that no clawed predator, no grazing herd, no scavenging bird possesses in the same way. They have a relationship with heat that can be taught. The flame no longer belongs only to lightning. It belongs uncertainly and dangerously onto memory. And from that memory grows a new kind of survival, one in which the landscape is not merely endured as it is found, but altered, warmed, illuminated, and slowly drawn into the widening circle of human control. A body is a record of its meals. Bones can tell stories of walking and lifting. Teeth can preserve the scars of chewing, and jaws can hold, in their shape, the pressure of thousands of generations spent breaking down food before it can become life. When fire enters the human story as a way to transform food, it does not merely add flavor or comfort. It changes the bargain between the outside world and the inside of the body. The raw landscape remains hard, fibrous, dangerous, and seasonal. But heat opens it differently. A root that resists the teeth can soften. A piece of meat that pulls like hide can loosen. Fish can become flaky and easier to strip from bone. Starch can become more accessible. Proteins can change their structure. Some toxins can be reduced. Many parasites and microbes can be killed before they enter the gut. Cooking is not magic, and it does not make every food safe, but it turns the meal into something partly pre-digested by flame. This matters because digestion is expensive. Every animal must spend energy to get energy, and the balance is never guaranteed. A food may contain calories in a chemical sense, yet still cost the body time and effort to chew, break down, and absorb. Raw food can be especially costly. Tough plant fibers protect nutrients behind cell walls. Starches in underground storage organs can pass through the digestive tract less efficiently if they are not altered. Raw meat requires chewing and tearing, and although it is rich, it can demand more effort than a cooked piece from the same animal. Heat changes this equation. It breaks structures, loosens tissues, and makes more of the meal available sooner. The lesser-known point is that cooking does not simply add calories, it can change how much of the existing energy a body can actually use. Human anatomy looks as if it has been shaped by this long external processing of food. Compared with the great apes, humans have relatively small teeth, smaller jaws, flatter faces, and reduced chewing muscles. The human gut is also not built like that of an animal spending most of its life fermenting large masses of raw leaves. These comparisons must be handled carefully, because evolution is not a neat diagram with one cause and one result. Tool use, meat eating, food sharing, pounding, slicing, drying, fermenting, changing climates, and social cooperation all matter. Still, the trend is suggestive. As food becomes more processed outside the body can afford, over evolutionary time, to invest less in massive chewing equipment and perhaps more in other systems. What survives in the record suggests a lineage increasingly committed to making food easier before swallowing it. Teeth preserve some of the story. Large jaws and heavy chewing muscles are useful when food is tough, gritty, and raw. But they come with costs. A skull built for enormous chewing force has a different architecture from a skull that can support a rounded brain case, a smaller face, and more delicate dental machinery. Early members of the human lineage do not all move in one straight line toward modern anatomy, and scholars still debate how different foods shaped different species. Yet the broad contrast is hard to ignore. Humans are not impressive chewers compared with many other primates. A chimpanzee can process tough foods with the strength that would exhaust a modern human. Humans, by contrast, become creatures of preparation. They cut, crush, pound, soak, grind, ferment, roast, boil much later, and share. Fire becomes one of the most important stages in this widening chain. Cooking also changes risk. A carcass in the sun is a dangerous clock. Fish pulled from a lake begins to decay. Meat carries parasites. Plant foods can carry chemical defenses. Early humans do not know bacteria, but their bodies know sickness and survival. Groups that learn to heat certain foods may reduce some hazards without understanding why. This does not mean ancient meals become clean or safe by modern standards. Smoke, ash, dirty hands, contaminated water, and partly spoiled food remain part of prehistoric life. But cooking can reduce the danger enough to matter. A child, an injured adult, an elder with worn teeth, or a pregnant woman may benefit from softer and safer foods. In evolutionary terms, advantages do not need to be perfect. They need only shift the odds again and again. The softness of cooked food may have changed social life as much as anatomy. Raw toughness favors the strong bite and the patient chewer. Cooked softness allows food to be shared across ages and conditions. A piece of roasted tuber can be eaten by someone with worn teeth. Flaked cooked fish can be given to a child. Tenderized meat can support an injured hunter, a nursing mother, or an elder whose knowledge remains valuable even when the body weakens. This is a quiet revolution. Fire does not only feed the strongest individuals, it can widen the circle of who can eat well. Survival is not only the survival of isolated adults at peak strength, it is the survival of infants, caregivers, experienced foragers, and those who remember where water remains when the season turns dry. At Gesher Benot Yaakov, the possible cooking of fish gives this transformation a concrete setting. Freshwater fish from an ancient lake are not merely scraps. They are a concentrated resource, easier to gather seasonally than large game. rich in nutrients, and potentially important for groups living close to water. The evidence from heated fish teeth has been interpreted as low-temperature cooking rather than simple burning, suggesting food placed near controlled heat instead of thrown into destructive flame. No one can reconstruct the exact recipe. There is no surviving leaf wrap, no preserved gesture, no hand still turning the fish over coals. But the possibility itself is striking hundreds of thousands of years ago. Early humans may be using fire not only to survive the night, but to alter the chemistry of dinner with care. Plant foods deserve equal attention because the romance of prehistory often overemphasizes meat. Underground tubers, seeds, nuts, fruits, and aquatic plants likely matter greatly in many environments. Heat can make some of these foods easier to digest and, in certain cases, less toxic. Starch is especially important. When heated with moisture, starch granules can gelatinize, making them more accessible to digestive enzymes. The evidence remains incomplete, partly because plants vanish more easily than bones and stone. Charred seeds, residues, starch grains on tools, and preserved plant remains offer glimpses, but much of plant eating disappears. No single explanation fully accounts for the human body. The story cannot honestly be reduced to cooked meat making large brains, or roasted roots shrinking jaws, or one hearth transforming evolution overnight. Bodies change slowly, and the evidence crosses many species, climates, and behaviors. But cooking offers one of the most elegant clues because it joins so many patterns at once: smaller teeth, altered digestion, softer foods, safer meals, wider sharing, reduced chewing time, increased energy access, and more flexible survival. It is both biological and cultural. The flame outside the body begins to shape the body from within. Wood from the landscape becomes flame. Flame changes food. Food changes digestion. Digestion changes energy. Energy changes what bodies can afford to build and maintain. The next step in the story lies inside the skull, where the most expensive organ in the human body waits for an answer to its oldest problem: how to feed a brain that is becoming hungrier than the old raw world was ready to support. The brain is not a silent passenger inside evolution. It is costly tissue, demanding, hungry, and unforgiving. Even at rest, the modern human brain consumes a remarkable share of the body's energy, far more than its weight alone would suggest. It cannot be switched off when food is scarce. It gives no direct strength to the jaw, no speed to the legs, no claw to the hand. To grow and maintain such an organ, a body must solve a difficult problem: where does the energy come from? And what other cost must be reduced to pay for it? Fire enters this question not as a simple answer, but as one of the most powerful changes in the economy of the body. Earlier hominins did not wake one morning with modern human brains. The enlargement of the brain unfolds across deep time, unevenly and through several species. Australopithecines already walk upright, but their brains remain modest compared with the later humans. Early Homo begins to show larger brains, more flexible tool use, wider-ranging behavior, and a growing ability to exploit varied foods. Homo erectus, appearing around 2 million years ago, carries the story into a new scale. Larger bodies, longer legs, smaller teeth than earlier robust forms, and brains expanding beyond previous limits. The timing is important, because some researchers have argued that regular access to higher quality food, including meat and possibly cooked food, helps make this shift possible. Yet the evidence remains incomplete. The earliest secure traces of controlled fire do not line up perfectly with the earliest increases in brain size. and that mismatch keeps the debate alive. This is where the cooking hypothesis becomes both compelling and contested. Its central idea is elegant. A large brain requires energy. The human digestive system is not built like the huge fermentation chamber of an animal, relying mostly on raw fibrous plants. If food is processed outside the body, especially through cooking, then the body can extract more energy with less chewing and digestive work. In this view, fire becomes a kind of external stomach, doing part of the labor before food is swallowed. Cooked starches become easier for enzymes to attack. Cooked meat becomes softer and may yield more accessible protein and fat. Heat reduces some pathogens and parasites, lowering the hidden costs of illness. Over many generations, such changes could support smaller guts, smaller jaws, shorter chewing times, and more energy available for a growing brain. But no single explanation fully accounts for the rise of the human brain. Meat eating may have begun before regular cooking and may have been crucial in itself. Stone tools allow earlier humans to cut flesh, crack bones, and reach marrow. Cooperative foraging spreads risk. Social learning makes difficult foods usable. Food sharing helps young brains grow through long childhoods. Climatic instability may favor flexible intelligence. Fermentation, drying, pounding, and slicing may all improve food before heat becomes routine. Scholars still debate whether cooking is the cause of brain expansion, a consequence of already growing intelligence, or part of a feedback loop in which better food, larger brains, and more complex behavior reinforce one another. The feedback loop may be the most human answer. A slightly larger brain helps a group remember more places, coordinate better, shape tools more carefully, and experiment with new foods. Better tools and better social cooperation provide richer diets. Richer diets support longer childhoods and more demanding brains. Fire, once controlled, intensifies this cycle. It makes some foods softer, safer, and more predictable. It allows nighttime social learning. It protects vulnerable members who carry knowledge. It extends the range of habitats where a group can live. A brain that can manage fire gains access to a technology that rewards memory and planning, and fire in turn helps feed the brain that manages it. Neither stands alone. Each makes the other more valuable. The brain is hungry not only in adults but in children. Human childhood is unusually long. A human child must grow not just a body, but a brain that takes years to mature. This makes caregivers essential. It also makes food quality essential. Soft, cooked foods may be especially important for infants after weaning, and for children whose teeth and jaws cannot yet process tough raw meals efficiently. A roasted root mashed by hand, a piece of cooked fish, softened meat, or starch-rich food altered by heat can feed bodies that raw foods might leave struggling. What survives in the record rarely shows childcare directly, yet every population depends on it. Fire may have entered family life not only as a tool of hunters and travelers, but as a quiet support for the smallest and slowest growing members of the group. A lesser-known aspect of this story lies in the gut. Digestion is not only human tissue doing work, it is also microbial life. The communities of microbes inside the digestive tract help break down foods and shape metabolism. Modern human gut microbiomes are not identical to those of other primates, and diet is one reason. Cooking changes the chemical and physical nature of food before microbes encounter it. It can reduce some microbial load while altering the substrates available to gut organisms. This relationship is difficult to reconstruct in deep prehistory, because ancient microbiomes rarely preserve across such timescales. Still, the idea matters. Fire may have influenced not only teeth, jaws, stomachs, and brains, but the invisible ecosystems inside the body. The human animal becomes, in part, a creature whose internal life is shaped by external heat. There is a danger in making the brain story too triumphant. A large brain is not simply better in every circumstance. It is expensive, vulnerable, and slow to build. It creates dependent children. It requires stable access to energy. It demands social systems that can support learning over many years. During famine, a large-brained species carries a heavy burden. During injury or isolation, intelligence alone does not guarantee survival. Fire helps offset some of these costs, but it also adds dependency. A group accustomed to cooked food, warmth, and nighttime protection may suffer when fire is lost. Evolutionary success often creates new needs. The more human ancestors depend on culture, the more dangerous it becomes when culture fails. This dependency may explain why fire becomes so deeply embedded once it takes hold. It is not merely an optional improvement. For later humans, it becomes part of the expected environment of the body. Meals are planned around it. Camps are organized around it. Sleep is arranged near it. Materials are selected for it. Children learn its danger and usefulness early. Over time, the cooked meal may become so ordinary that the anatomy shaped around it no longer reveals the struggle that made it possible. Modern people inherit the result: small mouths, vulnerable teeth, demanding brains, long childhoods, and bodies that often function best with food softened, processed, and made safe before it is eaten. The older raw world does not vanish completely. Humans can still eat raw foods, and many raw foods remain valuable. But the evolutionary center of gravity has shifted. The body no longer belongs entirely to the uncooked landscape. It belongs to a partnership between biology and technique. Fire is one part of that partnership, joined with stone tools, social care, shared knowledge, and environmental memory. The brain's hunger is answered not by one discovery, but by a way of life that gathers energy from the world with increasing skill. Around the flame, food becomes more than fuel. It becomes the material from which attention, memory, planning, childhood, and imagination can be sustained. The ancestors who tend the fire are feeding bodies, but they are also feeding the organ that will make fire itself more reliable, more meaningful, and more deeply woven into the fate of humanity. Cold changes the meaning of fire. In a warm landscape, flame is protection, cooking, light, and power. In a cold one, it becomes something closer to a second skin. The ancestors who move into harsher worlds do not merely carry a useful tool, they carry a pocket of climate. Around the hearth, air changes. Wet hands recover feeling. Infants can sleep against bodies that are not fighting the night alone. Meat can thaw, fat can soften, hides can dry, and stone can be worked when daylight fades early. Beyond the glow, frost gathers on grass, wind scrapes exposed skin, and darkness arrives with the weight of a season rather than a single evening. Fire does not remove danger from the Ice Age world, but it gives human groups a way to negotiate with it. The phrase Ice Age can make the past sound frozen everywhere, as if ancient humans walked endlessly across white plains beneath falling snow. The reality is more varied and more interesting. Glacial periods reshape the planet in uneven ways. Ice sheets expand over northern regions, sea levels fall, coastlines move, deserts widen, forests shrink or shift, and vast steppe landscapes stretch across parts of Eurasia. Some places are brutally cold, Others are dry, windy, open, and seasonal. In many regions, the challenge is not only low temperature but unpredictability, sudden storms, scarce wood, exposed camps, frozen ground, and animal herds that move according to rhythms humans must learn. Fire becomes one of the few technologies that can answer several of these pressures at once. For early humans and their relatives, cold is not an abstract discomfort, it is a direct threat to energy. The body must burn calories to stay warm. A cold night can turn hunger into danger. Wet clothing or wet fur coverings, where such coverings exist, can draw heat away. Bare skin loses warmth quickly in wind. Children cool faster than adults. The old and injured become vulnerable. A group that can create warmth outside the body reduces the cost of simply remaining alive. This matters because evolution is often shaped by margins. A few more children surviving winter, a few more elders living long enough to pass on knowledge, a few more successful cold season hunts or scavenging events can gradually alter what is possible. Fire also transforms shelter. A cave without flame can be dark, damp, and dangerous. A cave with flame can become a refuge, though never a perfect one. Smoke must go somewhere. Poor ventilation can make a protected space almost unlivable. Soot can gather on ceilings. Sparks can threaten bedding or stored materials. Still, the difference is profound. Light allows people to enter deeper spaces, avoid hazards, prepare tools, and remain in places that predators might otherwise dominate. Rock shelters, cave mouths, windbreaks, and constructed camps all change when fire is present. The hearth becomes the point around which space is organized. There is a warm side and a cold side, a place for fuel, a place for food, a place for sleeping, a place where children must not step too close. In colder regions, fuel itself becomes a problem. Fire is only as reliable as what feeds it. In some Ice Age landscapes, wood is scarce or seasonal. Open steppe can offer grasses, shrubs, bones, and dung, but not always dense forests. Dung fuel, used by later pastoral and traditional societies in treeless landscapes, reminds us that fire use is not simply a matter of gathering logs from a woodland floor. Ancient groups may have burned whatever local environments allowed, including small branches, driftwood, peat-like material, dry grasses, and perhaps animal dung in some settings, though direct evidence is difficult to secure for very ancient periods. What survives in the record suggests that fuel strategy must have mattered enormously. A group entering a cold, open landscape without knowing where to find burnable material would be carrying knowledge only halfway. The firelit Ice Age is also a world of animals. Mammoths, horses, reindeer, bison, woolly rhinoceroses, giant deer, cave bears, hyenas, wolves, and big cats occupy the broader landscapes of Pleistocene Eurasia, though the exact mix changes by region and time. Humans are not always top predators in this world. They are dangerous, intelligent, cooperative, and armed with tools, but they are also made of meat. Fire can help shift that balance. Many animals hesitate around flame, smoke, and human activity, though fire is not a magical wall. A hungry predator may still test the edge of a camp. Scavengers may circle nearby, but light reveals eyeshine. Smoke carries warning, and a group gathered around embers can defend itself more effectively than bodies scattered in darkness. In this sense, fire extends the senses. It lets humans see into the night and forces the night to show some of its movement. Cooking becomes even more important in cold worlds because fat and protein are not always easy to process raw. Large animals provide enormous resources, but using them fully requires skill. Meat must be cut, marrow extracted, organs eaten before they spoil, hides removed and processed, bones broken, tendons saved, and fat protected. Fire helps with several of these tasks. It can roast, soften, thaw, dry, smoke, and make food safer for storage or later eating. Smoke drying and heat drying are difficult to prove deep in the past unless preserved remains survive. Yet the logic of preservation in harsh climates is strong. A large carcass is too valuable to waste, and too large to consume all at once. Fire gives humans more ways to stretch a kill across time, even if the evidence for exact methods remains incomplete. There is a lesser-known technological side to cold and fire as well. In freezing conditions, materials behave differently. Wood becomes brittle, hide stiffens, sinew tightens, adhesives can fail. Frozen ground resists digging. Fire can warm stone and wood, soften resins, dry fibers, and help prepare materials for tools and clothing. Later, prehistoric people use heat in sophisticated ways to treat stone, process pigments, work bone, and prepare composite tools. Some of these practices are better documented in later periods than in the earliest phases of fire use. But they reveal a broader truth once humans understand heat. It becomes a workshop, not just a campfire. In cold environments, that workshop may be essential for repairing the things that make survival possible. The relationship between fire and clothing is especially intriguing. Direct evidence for early clothing rarely survives because hides, fibers, and sinews decay. Yet as humans and their relatives occupy colder regions, some form of body covering becomes increasingly likely. Fire would have supported this by drying hides, warming bodies when coverings were inadequate, and perhaps helping with scraping or smoking skins. The evidence remains incomplete, and scholars still debate when tailored clothing appears, but the larger pattern is clear. Fire, shelter, clothing, and social cooperation work together. None alone fully explain survival in the cold. Together they create a system. Neanderthals lived deeply inside this system. Across Ice Age Europe and Western Asia, they endure climates that shift dramatically over time. They use fire in many contexts, though the frequency and reliability of that use remain debated at certain sites. They hunt large animals, occupy caves and open-air locations, make sophisticated stone tools, and survive for hundreds of thousands of years in environments that would kill an unprepared modern person quickly. Their story will return later. But here they matter because they show that fire is not the possession of one narrow human line. It belongs to a wider human family learning to live with cold, darkness, and scarcity in different ways. For Homo sapiens, fire also becomes a passport into difficult country. As modern humans expand through Africa and into Eurasia, they encounter deserts, mountains, forests, coastlines, steppes, monsoon systems, and glacial frontiers. Fire helps turn unfamiliar places into livable ones. It allows camps where nights are cold. It makes new foods usable. It keeps insects away in wetlands and predators at a distance in open country. It hardens wooden points, warms sleeping spaces, and extends social time after short winter days. Yet it does not guarantee success. Populations vanish from regions, return later, shift with climate, and adapt unevenly. No single explanation fully accounts for where humans thrive and where they fail. Fire is a crucial advantage, not an escape from ecology. In the cold, then, the flame becomes more than heat. It is a portable boundary between the body and the indifferent atmosphere. It is a way of turning calories into warmth before the body has to spend its own. It is a signal to predators, a tool for food, a support for children, a dryer of hides, a maker of usable space, and a companion to migration. The Ice Age world remains immense beyond the hearth wind over mammoth grasslands, stars sharp above frozen rivers, caves breathing damp air, animals moving in the dark, but inside the circle, human life gathers itself. The old planet still rules the horizon, yet beside the embers, a small group has learned to carry a climate of its own. Night is one of the oldest borders in the human story. Before reliable fire, it arrives not as scenery but as command. Activity slows because vision fails. Hands lose precision. The ground becomes uncertain. Predators move with advantages humans do not possess. Cold deepens. Food cannot be easily prepared. Tools cannot be shaped with confidence. A group may remain close together, but the world of action contracts. With fire, that border does not disappear, but it changes shape. Darkness is pushed outward. A new kind of time opens between sunset and sleep, and inside that time, human life begins to thicken. The hearth turns night from a blank interval into a social space. Around a flame, people can see one another's faces after the sun is gone. This seems simple, but it is profound. Faces carry emotion, warning, attention, recognition, and memory. Hands become visible again. An older individual can show a younger one how to retouch a flake, scrape a hide, crack a bone, sort plant fibers, or place food near heat without burning it. A child can watch not only the result of an action, but the movement that produces it. Skill survives because it can be seen, copied, corrected, and repeated. What survives in the archaeological record is stone, ash, bone, and charcoal. But the human meaning of those objects often depends on vanished moments of teaching. Fire also creates stillness without sleep. In daylight, movement dominates. Groups search for food, carry infants, gather fuel, track animals, avoid danger, and respond to weather. At night, the fire draws bodies into a circle. It gives them a reason to stay. The same warmth that protects the body also gathers attention. This may have mattered for the growth of social intelligence. Around embers, individuals must negotiate space, food, warmth, smoke, and danger. They watch who shares, who withholds, who tends the flame, who ignores it, who comforts a child, who notices movement beyond the light. Cooperation is not an abstract virtue in such a setting. It is a nightly practical arrangement, and fire makes that arrangement visible. There is a tempting romance in imagining the first stories told around the first campfires. The evidence remains incomplete, because spoken words vanish almost entirely unless they later leave marks in art, ritual, or material culture. No archaeologist can recover the first tale from ash. Still, it is reasonable to say that fire creates conditions in which storytelling becomes more likely and more powerful. The glow holds a group together after the day's work is done. Darkness hides the wider landscape while flame lights the human circle. Memory can be shared without the immediate pressure of movement, a hunting route, a dangerous waterhole, an animal's behavior, a plant season, a death, a birth, a storm, a mistake with fire itself, all can be turned into remembered knowledge. Whether these moments were stories in the later sense or practical speech shaped by rhythm and repetition, night beside fire gives memory a stage. This matters because humans are not born knowing how to survive. Much of human adaptation is learned. A lion carries more of its hunting equipment in instinct and body. A human carries survival in community. Stone tool traditions, food knowledge, migration routes, fuel selection, shelter use, childcare, warnings about predators, and the handling of flame all depend on transmission. Fire strengthens that transmission by extending the hours during which learning can happen. It also makes learning safer in some ways. A child does not need to discover every danger alone if elders can demonstrate caution and repeat. The hearth becomes a place where experience outlives the body that first earned it. The old and injured may have gained special importance in this firelit world. In a harsh landscape, an individual who can no longer run fast or travel far might still know which wood burns in rain, where dry fuel can be found after storms, when fish gather in shallows, which tubers must be cooked longer, or how to preserve embers through the night. Fire can make such knowledge more useful, because it creates work that does not always require speed. Tending embers, preparing food, watching children, repairing tools, and remembering procedures can all happen near the hearth. No single explanation fully accounts for the evolution of long human lives after reproduction, and scholars still debate the roles of grandparenting, food sharing, and social knowledge. But fire likely strengthened the value of those who carried memory. Night around fire may also have changed emotion. The dark beyond the glow remains dangerous, but the circle of light creates a shared refuge. Fear can become collective rather than solitary. A sound in the distance is heard by many ears. A shadow beyond the reeds is watched by several eyes. A child frightened by animal calls can move closer to warmth and familiar bodies. This does not make prehistoric life gentle. It does not erase conflict, hunger, injury, or loss. But it gives fear a place to gather, and gathered fear can be managed. The emotional center of the group may have been built as much around warmth as around language. The hearth also alters the organization of space. A camp with fire has zones. Closest to the flame is heat, danger, cooking, and light. Farther away are sleeping bodies, stored materials, discarded bones, fuel piles, tool-making areas, and edges where smoke thins. People learn where to sit according to age, task, and need. Too close, and sparks burn skin. Too far, and cold returns. Wind direction matters. Smoke decides which side of the fire is tolerable. These daily adjustments rarely appear as grand moments in human evolution, but they are the texture of culture. A group that shares fire must share rules. Even if those rules are never formally spoken, there is another, quieter consequence. Fire makes waiting more bearable. Cooking requires delay. Meat must roast, roots must soften, embers must mature, wet wood must catch, a flame must be coaxed rather than forced. Around fire, humans practice patience with a visible reward, the ability to wait, watch, and time and action matters in hunting, tool-making, childcare, and social life. Fire teaches through failure. Food burned black is wasted. Food pulled too early remains tough. Embers neglected die. Fuel added carelessly smothers the flame or sends sparks into sleeping space. The hearth is a school of consequence. From this school grows a deeper human rhythm. Day becomes foraging, travel, hunting, gathering, and exposure. Night becomes cooking, repair, teaching, social bonding, watching, and memory. The division is never perfect, and different groups in different environments would live by different schedules. But once fire becomes reliable, The sun no longer owns all useful time. Humanity gains an afterlife within each day. A second period of activity that belongs not to the sky but to the group's ability to hold light against darkness. This may be one of fire's most underestimated gifts. It does not only feed the brain through cooked food, it feeds the social world in which a brain becomes useful. Intelligence alone is fragile if it cannot be shared. Memory fades if it cannot be passed on. Skill dies if it remains trapped in one body. Around the fire, knowledge becomes communal. The flame lights hands, faces, tools, food, wounds, children, elders, and the invisible bonds between them. The night outside remains ancient and full of movement, but within the glow, time has been remade. A few extra hours after sunset may seem small beside the scale of evolution, yet across thousands of generations, those hours become a vast hidden territory. In that territory, humans do not merely stay awake, they become more deeply human together. Fire begins as warmth and protection, but it does not remain only that. Once human hands learn to keep heat near them, the world of materials changes. Wood is no longer just a branch, a digging stick, a handle, or fuel waiting to burn. Stone is no longer only something struck, flaked, and discarded. Bone, hide, resin, clay, plant fiber, meat, fish, seeds, and even the landscape itself begin to answer differently when touched by controlled heat. The hearth becomes a workshop. It is still a place of danger and food, still a circle of light in the night, but it also becomes a quiet laboratory where early humans discover that materials have hidden states. Heat can harden, soften, dry, crack, bend, preserve, ruin, and transform. The same force that cooks a meal can also change the tools that make the next meal possible. Wood is one of the oldest and most important materials in human life, yet it is one of the least visible in deep archaeology. Stone tools survive and dominate museum cases, but many ancient worlds were probably full of wooden technologies now lost: digging sticks, carrying poles, spear shafts, wedges, containers, frames, traps, handles, and shelters. Wood rots, burns, splinters, or vanishes into soil unless conditions are unusually favorable. This makes the early technological record look harder and more stony than life itself probably was. Fire sharpens that hidden wooden world. A wooden point placed carefully near heat can become drier and harder, though too much heat will weaken or char it. A shaft can be straightened over warmth. A branch can be bent, cured, or stripped more easily. The evidence remains incomplete, but what survives in later and rare preserved examples suggests that early humans and their relatives understood wood far more deeply than the record usually admits. The idea of a fire-hardened spear carries a simple drama: a hunter turning a wooden point slowly above coals, strengthening it before entering a world of large animals. The reality is more complicated. Some claims of very ancient fire-hardened wooden tools are debated, and not every darkened wooden point proves intentional heat treatment. Wood can char accidentally. It can darken in wet sediments. It can be damaged after burial. Still, the principle is real. Heat can alter wood, and humans who live close to fire would have many chances to notice the difference between green wood, dry wood, scorched wood, and carefully cured wood. In this way, fire teaches through repeated accidents. A stick left too close becomes brittle. Another, warmed and dried more slowly, becomes better suited to thrusting, digging, or carrying. Technology often begins where attention learns from failure. Stone also changes in fire, though not always safely. Many stones crack or explode when heated, especially if moisture is trapped inside them. Others alter in ways that make them easier to flake. Heat treatment of stone is well documented in later prehistoric contexts, where carefully controlled heating improves the fracture quality of certain rocks used for tools. This is not merely throwing stones into flames. It requires knowledge of material, temperature, timing, cooling, and risk. A stone heated too quickly can shatter. A stone cooled badly can fracture before it becomes useful. The practice reveals a mind thinking ahead. Heat is applied not for immediate warmth or food, but to prepare a material for future shaping. Scholars still debate when and where such techniques first emerged in different regions, but the broader meaning is clear. Fire allows technology to become staged across time. A tool can begin as raw stone, pass through heat, and only later become a blade, scraper, or point. This staged thinking may be one of fire's deepest contributions to human behavior. Cooking already requires delayed reward, but material transformation pushes that delay further. A stone is heated today so it can be flaked tomorrow. Hide is smoked or dried so it can be used later. Meat is preserved so it can feed the group beyond the moment of killing. Wood is cured before it becomes a weapon or tool. The hearth turns survival into sequence. It teaches that an object can pass through preparation before usefulness. That may sound obvious to modern minds surrounded by manufactured things, but in deep prehistory, it is a profound habit. It means seeing not only what something is, but what it can become after the right process. Smoke is part of this process. It is often treated as a nuisance, and it certainly is one. Smoke stings eyes, irritates lungs, clings to hair and skin, blackens cave ceilings, and can make enclosed shelters dangerous. Yet smoke also has uses. It can repel insects. It can help dry meat or fish. It can alter hides. It can discourage some animals. It can signal presence across distance. A smoky fire is unpleasant, but in wetlands or insect-heavy seasons, unpleasant smoke may be better than being eaten alive by biting flies and mosquitoes. Around ancient lakeshores, rivers, and marshes, this would have mattered. Fire's value is not limited to flame. Sometimes the byproduct is the tool. Food storage is another area where fire quietly changes the human future. A cooked meal solves hunger now, but preserved food solves uncertainty. Drying, smoking, roasting, and reheating can extend the usefulness of meat, fish, seeds, and plant foods. Though the exact antiquity of many preservation methods is difficult to prove, a fish cooked and eaten immediately leaves one kind of trace. Fish dried on racks over smoke may leave almost nothing unless bones, hearths, or residues survive in the right arrangement. Yet the logic is powerful. Seasonal abundance can overwhelm immediate appetite. A lake may yield fish in pulses. A large animal kill can provide more meat than a group can consume before decay begins. Fire gives humans a way, however imperfect, to slow loss. It turns abundance into time. At Gesher Beno Yaakov, the ancient lakeshore again offers a glimpse of this wider fire economy. The charcoal fragments there suggest awareness of different woods in a wetland environment. Fish remains suggest food processing near heat. Stone tools and plant remains show a broader life, organized around the resources of water, shore, and surrounding land. It is not necessary to imagine a modern camp with neat divisions and fixed hearths. The ancient reality may have been messier. shifting with season, weather, and opportunity. But what survives in the record suggests that fire is embedded in a network of behaviors, fuel selection, food processing, tool use, and repeated occupation of a rich landscape. The flame is not isolated, it belongs to a system. Eventually, fire also becomes a way to manage land, though this part of the story must be treated carefully across deep time. Later human societies around the world use controlled burning to clear vegetation, encourage fresh plant growth, drive game, reduce pests, maintain travel corridors, and shape entire ecosystems. In very ancient periods, proving deliberate landscape burning is much harder. Natural fires also shape grasslands and forests, and separating human intention from climate-driven burning can be difficult. Still, the possibility matters because it shows the direction of the relationship. Fire begins as something found in the landscape, then becomes something carried through the landscape, and later becomes something used upon the landscape. The boundary between surviving in an environment and modifying it grows thinner. This transformation is not always benign. Fire can destroy resources, overexpose soils, drive animals away, burn shelters, and injure people. A tool that changes landscapes can also damage them. Even small groups must learn when not to burn. The human relationship with fire is therefore never just mastery. It is negotiation and sometimes misjudgment. This too makes it human. A stone knife cuts whether wisely or foolishly. Fire amplifies intention and error alike. It rewards planning but magnifies carelessness. By the time fire becomes a regular part of human technology, the hearth is no longer merely the end of the day. It is where raw things enter and changed things leave. Wet wood becomes fuel. Tough food becomes nourishment. Smoke becomes protection or preservation. Stone becomes more workable. Hide becomes drier. A branch becomes a tool. A dark camp becomes a place of repair. The old world supplies the materials, but heat reveals their hidden possibilities. Around the embers, humans learn one of the principles that will follow them all the way into pottery. Metal, engines, and industry matter is not fixed. Under the right conditions, it can be transformed. Long before cities glow on the horizon, that lesson begins in the small red heart of a fire, watched by people whose tools, meals, landscapes, and futures are slowly being remade by smoke and heat. Neanderthals enter the fire story not as crude shadows waiting for modern humans to arrive, but as experienced people of cold country, stone country, and difficult seasons. For hundreds of thousands of years, they live across Europe and parts of Western Asia, through shifting climates that repeatedly redraw the map of forests, grasslands, rivers, glaciers, and animal ranges. Their world is not permanently frozen, but it is often harsh enough to test every weakness in the body. They face winter darkness, wet caves, open steppe winds, large predators, and prey animals that demand strength, planning, and close-range danger. In such a world, fire is not an ornament of intelligence. It is woven into the daily struggle to remain alive. The Neanderthal body itself seems built for demanding environments. Broad chests, powerful limbs, large noses, strong hands, and muscular frames suggest people adapted to strenuous lives in often cold or variable climates. But muscle alone cannot solve the Ice Age. A strong body still loses heat. A skilled hunter still needs sleep. A group that kills a large animal still must process meat, fat, hide, bone, and sinew before decay. Weather, or scavengers take their share. Fire helps answer these problems. It warms shelters, cooks food, dries materials, lights cave mouths, and may help keep some predators away. Yet the evidence is not as simple as imagining every Neanderthal family sitting beside a permanent blaze. Scholars still debate how reliable Neanderthal fire use was in different regions and periods, and that debate reveals how complex their survival really was. At many Neanderthal sites, hearths and burned materials show that they used fire repeatedly. Caves and rock shelters across Europe preserve ash layers, burned bones, charcoal, reddened sediment, and stone tools altered by heat. In some places, the evidence suggests organized hearth zones, where activities cluster around fire in ways that feel familiar even across deep time. Food is processed nearby. Tools are made or repaired. Bones are broken. Space is structured around heat and light. What survives in the record suggests that Neanderthals were not strangers to flame. They understood it well enough to bring it into living spaces and make it part of their routines. But there is a puzzle. Some Neanderthal occupations, including sites in cold regions, show little or no clear evidence of fire. This absence has led to competing interpretations. One view holds that Neanderthals had fire, but the record fails to preserve it consistently. Ash disappears, charcoal decays, hearths are disturbed, and open-air camps are destroyed by erosion. Another view suggests that Neanderthal fire use may have been less reliable in some times and places than once assumed. Perhaps they could maintain fire when it was available, but did not always make it easily. Perhaps fuel scarcity, wet conditions, group mobility, or seasonal occupation affected whether hearths were used. No single explanation fully accounts for the patchiness. The problem remains one of the most intriguing contradictions in the archaeology of Neanderthal life. Fire appears important, but not always visible where expectation says it should be. The distinction between using fire and making fire matters here. Later modern humans certainly master multiple ways to create flame, but for Neanderthals the evidence is harder to pin down. They may have been fully capable of fire-making in at least some contexts, and some researchers have looked for signs of percussion fire-starting using minerals such as pyrite. But proving the act is difficult. A hearth shows that fire existed. It does not automatically show how the fire began. A piece of mineral or a struck stone may suggest possibility, but the gesture of spark-making vanishes. The evidence remains incomplete, and so Neanderthal fire-making sits in that difficult zone between what seems plausible and what can be firmly demonstrated at every site. Their use of fire may have gone beyond warmth and cooking. One of the most remarkable clues comes from birch tar, an adhesive known from Neanderthal contexts. Birch tar is not a casual substance. It requires heating birch bark under conditions that limit oxygen, causing it to release a sticky material useful for hafting stone tools onto wooden handles or shafts. The exact methods Neanderthals used are debated, and researchers have shown that some techniques can be simpler than once assumed. Still, the production of adhesive from heat is significant. It suggests an understanding that fire can transform a material invisibly, not merely burn its surface. A piece of bark becomes glue. A stone flake becomes part of a composite tool. This is fire as chemistry, long before chemistry has a name. Cooking among Neanderthals is equally important but difficult to reconstruct in detail. Burned animal bones occur at many sites, and Neanderthals clearly processed large prey, including deer, horses, bison, and other animals depending on region and climate. They also used plant foods more than older stereotypes allowed. Traces of plant starches, cooked plant residues in dental calculus, and evidence of varied diets in different environments have helped overturn the image of Neanderthals as simple meat-eating brutes. Fire would have made both meat and some plant foods easier to eat. It could soften tough tissues, warm marrow-rich bones before cracking, roast roots, and reduce some hazards in food. Yet it is still hard to know how often they cooked, how they preferred certain foods, or how much their diets varied by season. What survives in the record suggests flexibility rather than simplicity. The hearth may also have shaped Neanderthal social life. They lived in small groups, likely with close kin ties, learn traditions, care for injured individuals, and repeated knowledge of landscapes. Fire would have supported all of this. Around it, hides could dry, tools could be repaired, children could watch adults work, and the injured could remain warm. Evidence from Neanderthal fossils shows that some individuals survived serious injuries or physical limitations, implying social care. Fire does not prove compassion, but it creates conditions that make care easier. Warmth, cooked food, light, and sheltered space help vulnerable bodies endure. In the cold months of Pleistocene Europe, such support may have meant the difference between an injured person becoming a burden too great to carry and remaining a living holder of memory. There is also the matter of smoke. Neanderthals often occupied caves and rock shelters, places where smoke could be both useful and dangerous. Poor ventilation would irritate lungs and eyes, especially with repeated exposure. Soot on cave ceilings and ash deposits can reveal fire use, but they also hint at the discomfort of living with flame in enclosed spaces. The choice to use fire indoors therefore reflects calculation. Warmth and protection must be weighed against smoke, fuel demands, and the risk of suffocation or respiratory stress. Ancient hearths are not cozy in the modern romantic sense. They are practical centers surrounded by compromise. Neanderthals remind us that fire does not belong to a single heroic branch of humanity. It belongs to a broader human family, one with several kinds of people learning, failing, adapting, and surviving under different pressures. Modern humans did not invent warmth, cooking, or hearth-centered life from nothing. They inherited and developed behaviors that had deep roots among earlier humans and close relatives. When modern humans eventually enter Neanderthal landscapes, they are not meeting animals without culture. They are encountering people who know stone, prey, weather, shelter, and fire in ways shaped by immense time. And yet Neanderthals disappear. Fire does not save them from the combined pressures that later close around their population's climate instability, small group size, ecological stress, competition, interbreeding, and the spread of Homo sapiens. The reasons remain debated, and no single explanation fully accounts for their disappearance. But their hearths remain as dark witnesses. They show that flame was not a simple dividing line between them and us. Instead, it was a shared inheritance, a technology that illuminated more than one human path. Beside Neanderthal embers, the story of fire becomes wider and more humbling. It is no longer only about how modern humans became human. It is about how several kinds of humans stood against cold and darkness, each drawing from the same dangerous light. Far to the east of the classic Neanderthal world, beyond the familiar caves of Western Europe and the long-studied valleys of the Near East, the human story enters a colder, higher, more elusive landscape. The Altai Mountains rise where Siberia, Central Asia, and Inner Asia meet, a region of forests, steppe, rivers, snow, limestone caves, and ancient corridors of movement. Here, in Denisova Cave, the history of fire becomes entangled with one of the strangest discoveries in human origins, a kind of human known first not from a skull, not from a burial, not from a painted wall or a complete skeleton, but from DNA hidden inside fragments so small they might once have been overlooked, a finger bone, a few teeth. Later, pieces of bone identified only after molecular analysis. From these remnants emerged the Denisovans, a human population whose body is mostly missing, whose culture remains shadowed, and whose genetic legacy still lives in some people today. Denisova Cave matters because it is not just a shelter, it is a crossroads preserved in stone and sediment. Over immense stretches of time, different human groups occupy or visit the cave and its surroundings. Neanderthals are there, Denisovans are there. Modern humans later pass through the wider region. The cave sediments hold tools, animal bones, ornaments in later layers, traces of occupation, and microscopic evidence that can be read with methods earlier generations of archaeologists did not possess. Fire appears in this world as part of cave life, but the problem is attribution. A hearth or burned bone in a layer does not always announce which human group made it. Denisovans, Neanderthals, and later modern humans overlap in complex ways across time. The evidence remains incomplete, and scholars still debate how to connect specific behaviors to specific people when the physical remains are so scarce. This uncertainty makes Denisovans both thrilling and frustrating. Neanderthals have skeletons, tools, injuries, faces that can be reconstructed with caution, and a long archaeological tradition behind them. Denisovans have genomes. Their discovery changed the scale of human origins research because it revealed that the past contained populations whose bones had barely survived, but whose DNA could still redraw the map. Genetic evidence shows that Denisovans are close relatives of Neanderthals, sharing a common ancestry before diverging into distinct lineages. They also interbred with both Neanderthals and modern humans. One individual from Denisova Cave, often known for having a Neanderthal mother and a Denisovan father, proves that these human groups did not always live behind clean biological walls. Their worlds touched, their bodies met, their descendants carried pieces of those encounters forward. In a story about fire, Denisovans remind us how much behavior can disappear when bodies do. It is reasonable to suspect that Denisovans used fire because they belong to a human world in which fire use is widespread among Middle and late Pleistocene populations, especially in cold and demanding environments. Denisova Cave itself contains evidence of repeated occupation where fire-related traces occur across layers, but caution is necessary. To say Denisovans certainly sat beside a particular hearth requires stronger association than the record often gives. A burned patch may belong to Neanderthals in one period, Denisovans in another, or later humans elsewhere. What survives in the record suggests that flame was part of life in the Altai cave world, but the exact Denisovan relationship to hearths, cooking, fuel choice, and fire-making remains partly hidden behind the poor survival of identifiable remains. The environment makes fire's importance easy to understand. The Altai is not a gentle tropical refuge. During Pleistocene climate swings, the region shifts between colder, drier, more open conditions and milder phases with different vegetation and animals. Winters can be severe. Caves offer shelter, but shelter without warmth is not enough. A group living or resting near the cave must manage cold, darkness, predators, and the processing of food from a varied landscape. Large herbivores move through the region. Carnivores also use caves and compete for space. Fire would make the cave mouth more livable, help process meat and plant foods, dry materials, and extend activity beyond short winter daylight. It would also create the same social center seen elsewhere in human evolution, a place where bodies gather, tools are repaired, and knowledge survives through watching. Denisovan adaptation may have reached far beyond the Altai. Ancient DNA and genetic traces in living populations suggest Denisovans were not a small cave-bound curiosity. Their ancestry appears in varying amounts among some present-day populations in Oceania, parts of Southeast Asia, East Asia, and indigenous groups in different regions. Though the exact routes and populations involved remain debated, this genetic pattern implies that Denisovan-related groups, or closely related populations, occupied a wide and complex range across Asia. Some may have lived in forests, some in mountains, some near rivers, some in cold steppe margins, and others in environments that left few bones behind. Fire, in such a broad world, would not have had one meaning. It would be warmth in the north, insect smoke in wetlands, cooking heat near rivers, protection in open country, and perhaps a necessary companion in high places where cold and low oxygen make every calorie matter. The high altitude clue is especially powerful. A version of the EPAS1 gene associated with adaptation to low oxygen in Tibetans appears to have come from Denisovan-related ancestry. This does not mean Denisovans as a whole were mountain specialists in one simple sense, nor does it prove a single dramatic migration into Tibet, but it shows that genetic inheritance from Denisovan-related humans helped later modern humans live where the air is thin and the body is under constant stress. High altitude magnifies the importance of energy, warmth, and shelter. Fire cannot solve low oxygen, but it can support survival by warming bodies, cooking food, melting snow or ice where needed, and making camps more secure in exposed landscapes. The Denisovan legacy therefore reaches into one of the most extreme forms of human adaptation, even if the daily lives behind that legacy remain mostly invisible. Denisovans also complicate the idea of progress. They are not simply a missing step on the way to modern humans. They are a parallel humanity, successful enough to endure across long spans, widespread enough to leave genetic traces across Asia and beyond, and distinct enough to reveal that human evolution was never a single road. Their relationship with fire, like so much else about them, must be reconstructed from indirect clues. Perhaps they cooked meat and plants in ways similar to Neanderthals and modern humans. Perhaps they used caves seasonally, following animals and climate. Perhaps they had regional traditions now lost because the tools cannot yet be confidently assigned. Perhaps some lived in landscapes where fire traces disappeared entirely. No single explanation fully accounts for the silence around their culture. That silence is part of their power. Around the imagined Denisovan hearth, the narrator must resist filling every shadow. There is no complete Denisovan face looking back from the flame. There is no full camp preserved in perfect detail. There are only teeth large enough to surprise researchers, tiny bones with enormous genetic consequences, cave sediments, stone tools whose makers are not always certain, and fragments of ancestry still carried in living bodies. Fire likely warmed their nights, changed their meals, and helped them endure landscapes that would have challenged any human group. But the exact gestures, the way a Denisovan hand placed wood on embers, the foods chosen, the stories remembered, the children warned away from sparks are gone. Still, the firelit East leaves a lesson as important as any ashlayer. Humanity was not made by one people alone. The long experiment with flame belonged to a braided family of humans, Neanderthals in western cold lands, Denisovans in Asian shadows, modern humans moving through changing worlds, and perhaps other populations still unnamed. They met, separated, adapted, vanished, and left traces in one another. In Denisova Cave, the glow of fire falls across a deeper mystery than technology alone. It falls across the realization that some human worlds disappeared almost completely, not because they were unimportant, but because time is ruthless in what it chooses to preserve. What remains is enough to show that the ancient night was shared by more than one kind of human, and that the embers of their lives have not entirely gone cold. Movement is one of the oldest habits of the human family, long before maps, borders, ships, roads, or names for continents. Human ancestors follow water, animals, coastlines, river valleys, stone sources, seasons, and the slow pressure of hunger. They move because climates shift. They move because forests open into grassland, lakes shrink, herds migrate, volcanoes disturb familiar ground, children grow, groups divide, and opportunity appears beyond the known horizon. Fire moves with them, at first perhaps as embers guarded from place to place, later as a method carried in the hands and memory. It is not the only reason humans expand, but it changes what expansion means. A group with fire does not enter a new landscape empty-handed. It carries warmth, light, cooking, protection, and a small controlled version of the environment it has left behind. The earliest great movements of the human lineage begin long before modern humans exist. Homo erectus and related early humans spread beyond Africa into parts of Eurasia in deep time, reaching landscapes that differ sharply from the ancestral African settings. The details remain debated because fossils are scattered and archaeological traces are uneven, but the general pattern is clear. Early humans become travelers across ecological boundaries. They appear in regions with different animals, different plants, different seasons, and different risks. Fire may not have been fully reliable at the beginning of these expansions, and scholars still debate how much early dispersal depended on it. But as fire use becomes more regular, it gives moving groups a powerful buffer against unfamiliar conditions. It allows them to carry a kind of behavioral home into places their bodies alone may not yet fit. This is especially important because migration is not simply walking into empty land. Every new environment contains problems that local animals have spent generations solving through anatomy and instinct. Humans arrive with flexible bodies, tools, and social learning, but also with vulnerabilities. They are not the fastest runners, not the strongest biters, not the best night hunters, not the best insulated mammals, and not the safest sleepers. Fire helps compensate. In open grassland, it can discourage predators and reveal movement after dark. In forests, it can clear small spaces, dry damp materials, and smoke insects. Near rivers and lakes, it can cook fish and aquatic plants. In cold uplands, it can warm bodies and make shelters usable. On long journeys, it can transform uncertain foods into safer meals. The flame becomes an answer not to one environment, but to many. The movement of fire also changes the meaning of camp. For a purely mobile animal, rest is wherever the body stops. For humans with fire, rest becomes a constructed place, even if only for one night. A camp may form around a hearth, a windbreak, a cave mouth, a fallen tree, a gravel bar, or a sheltered hollow. Fuel is gathered, stones may be arranged, food is prepared, tools repaired, bodies warmed, and children drawn toward the center. Then the group moves again, leaving behind charcoal, broken bone, flakes of stone, and altered sediment if preservation is kind. A path of human expansion is therefore not only a line of footprints, it is a chain of temporary worlds, each built around the ability to make a place habitable for a little while. Fire may have widened the menu during migration, and this matters more than it first appears. A group entering unfamiliar country cannot rely only on foods it already knows. New plants may be edible, poisonous, tough, bitter, or useful only after processing. New animals may require different hunting strategies. New climates change what is available and when. Cooking reduces some of this uncertainty. It does not make unknown foods automatically safe, but it can make many tough or marginal foods more usable. Roots that would be unpleasant or difficult raw may become edible after heat. Meat can be safer and easier to divide. Fish, shellfish, eggs, seeds, and plant storage organs can be processed in varied ways depending on the landscape. Fire gives migrants flexibility, and flexibility is survival stretched across geography. The relationship between fire and water is particularly important. Rivers, lakes, wetlands, and coasts often serve as corridors of movement because they provide food, routes, and recognizable features across unfamiliar terrain. But wet places bring their own challenges: damp wood, insects, mud, disease, sudden floods, and foods that spoil quickly. Smoke can repel biting insects. Heat can cook fish and shellfish. Fire can dry clothing or coverings, preserve some foods, and warm bodies after immersion or rain. At ancient lakeshores such as Gesher Benot Yaakov, the combination of water resources and fire-related evidence suggests how powerful this partnership could be. A watery landscape is not merely a source of fish. It is a living system that requires knowledge, timing, and processing. Fire turns more of that system into nourishment. Across colder frontiers, fire becomes even more decisive. Human groups moving into Europe, Northern Asia, or highland zones face shorter growing seasons, lower temperatures, snow, frozen ground, and seasonal scarcity. Fire does not replace clothing, shelter, hunting skill, or social cooperation, but it strengthens them all. It dries hides and fibers. It warms sleeping places. It allows food processing when cold makes raw foods harder to handle. It supports older individuals and children through long nights. It reduces the immediate cost of exposure. A population without reliable fire can still survive in some cold conditions through other adaptations, but the margin narrows. With fire, the edge of the possible moves outward. Mountains add another layer. At altitude, cold can combine with thin air, intense sun, unstable weather, and sparse fuel. The Denisovan genetic legacy linked to high-altitude adaptation in Tibetans reminds us that ancient humans and their relatives did not simply skirt every extreme place. Some adapted, directly or indirectly, to severe environments. Fire cannot create oxygen, and it cannot erase altitude sickness, but it can support the daily life around such adaptation. It helps conserve energy by warming camps. It cooks foods that might otherwise demand too much chewing and digestion. It melts snow or ice when liquid water is not available. Though fuel costs may make this difficult, it turns a hostile shelter into a usable one. In high places, every advantage is amplified because every mistake is costly. Fire may also have shaped how groups moved socially. A migrating band must decide what to carry, where to stop, who gathers fuel, who watches children, who knows the next water source, and whether embers should be preserved during travel. Such decisions bind movement to memory. Routes are not just geography, They are sequences of usable places. A good camp is not simply flat ground. It is flat ground near fuel, water, food, shelter, and safety. A river crossing is not only a crossing. It is a place where wet bodies must be warmed, tools recovered, children protected, and perhaps food cooked before the next stage. Fire turns movement into planning. This planning does not mean ancient migration was always heroic or successful. Groups can fail, a cold spell can kill. Fuel can be absent, a storm can extinguish embers. New foods can poison, predators can pressure camps. Conflict with other human groups can arise. Populations can retreat, vanish, or blend into others. The archaeological record often preserves arrivals better than failed attempts, because failure leaves fewer durable signs. What survives in the record suggests expansion, but behind every successful spread there may have been many forgotten dead ends. Fire improves the odds, it does not guarantee the outcome. By the time Homo sapiens expands widely across the planet, fire is deeply woven into the human way of moving. Modern humans carry not only tools and bodies, but traditions how to start flame, which fuel works, how to cook certain foods, how to protect children from sparks, how to sleep near warmth without suffocating in smoke, how to leave one hearth and build another. The moving flame becomes a bridge between landscapes. It allows humans to cross from savanna to woodland, from river to coast, from lowland to upland, from temperate regions into cold frontiers. It helps turn the unknown into something that can be tested, inhabited, and remembered. The image is simple, but its meaning is vast. A small group walking under a changing sky, carrying tools, children, gathered food, and perhaps an ember protected from the wind. Behind them lies a place already known. Ahead lies country that has not yet entered their stories. The ember is fragile. It can die in rain, fall from its container, or be smothered by careless packing. Yet while it lives, it is more than heat. It is continuity. It is the old camp traveling inside the new journey. Across deep time, humans do not merely spread by adapting their bodies to every place. They spread by carrying a transforming relationship with fire, and with it the ability to make temporary circles of familiarity under unfamiliar stars. The deeper fire seems to enter the human story, the stranger its absence becomes. By this point in the long arc, flame appears almost indispensable. It cooks food, warms bodies, protects camps, extends night, supports migration, transforms materials, and creates a social center where knowledge can gather. It seems so useful that the mind begins to expect it everywhere humans go. Yet the archaeological record refuses to behave so neatly. In some ancient places, fire appears with persuasive force. In others, where fire would seem equally necessary, the evidence is faint, disputed, or missing. The result is one of the most important mysteries in the study of early humanity. If fire helped make humans so successful, why does its trail through deep time look so uneven? Part of the answer lies in preservation. Fire is a poor witness to itself. A stone tool may sit in the ground for hundreds of thousands of years and still keep its sharp edge. A tooth may survive long enough to reveal diet, ancestry, or age. But ash is fragile. Charcoal can crumble, dissolve, blow away, or be moved from one layer to another. Burned bone can be scattered by animals or water. Hearths on open ground can vanish under erosion. Flood deposits, roots, burrows, trampling, and later fires. In a cave, sediments may preserve ash more safely, but even there, water, collapse, repeated occupation, and animal disturbance can blur the record. The absence of fire evidence is therefore never simple. It may mean fire was not used, or it may mean fire was used in a way the earth did not preserve. Still, preservation cannot explain everything. Some sites are well preserved and still show little clear burning. Some regions display long stretches where stone tools and animal bones survive, but hearths are rare. This forces archaeologists to consider uncomfortable possibilities. Perhaps early humans did not use fire as constantly as later humans did. Perhaps some groups used it only seasonally, when fuel and weather allowed. Perhaps some could preserve embers but not reliably make fire, so they lived through periods without it. Perhaps fire use spread unevenly, appearing strongly in some traditions and weakly in others. No single explanation fully accounts for the pattern. The record suggests not a simple invention followed by universal adoption, but a long, irregular history of learning, losing, adapting, and repeating. The difference between occasional fire and habitual fire is crucial. A group may gather around a natural blaze after lightning strikes and use the heat for a night. Another may carry embers for days, preserving flame with great care but still depending on a lucky beginning. A third may know how to create sparks under good conditions but fail in rain, wind, or fuel scarcity. A fourth may build hearths so routinely that fire becomes part of every camp. Archaeology often compresses these very different behaviors into the same category, evidence of burning. Yet from the point of view of human life, they are not the same. Occasional fire is an opportunity. Habitual fire is infrastructure. This unevenness may also reflect ecology. Fire depends on fuel, and fuel is not equally available everywhere. Wet forests can provide wood but make dry tinder difficult. Open grasslands may burn naturally but not always provide long-lasting logs. Cold steppe environments can be fuel poor, forcing groups to use small shrubs, bones, grasses, or dung where available. Tropical environments may preserve organic traces poorly. River valleys may provide driftwood but also floods that erase camps. A group living in a fuel-rich woodland leaves one kind of fire record. A group crossing an open, wind-swept plain may leave another or none at all. What survives in the record suggests behavior, but it also reflects the stubborn material reality of landscapes. Climate adds another complication. During wetter periods, natural fires may be less common, fuel may be damp, and ember preservation harder. During dry periods, wildfires may be common, making it harder for archaeologists to distinguish human-controlled burning from natural burning. Cold periods may increase the need for warmth while reducing available fuel. Warm periods may reduce the urgency of fire while increasing the value of cooking, insect smoke, and predator protection. Human fire use is therefore not only a technological question, it is a climate question. The same skill may leave different traces under different skies. There is also the possibility of cultural difference. Early humans and their relatives were not a single uniform population spreading one identical toolkit across the world. They lived in small groups, separated by distance, climate, resources, and time. Traditions can emerge locally. They can spread. They can fade. They can be forgotten if a knowledgeable person dies, if a group fragments, or if a population passes through a bottleneck. Modern people often assume that once a useful technology exists, it must remain forever. Deep prehistory may not work that way. Knowledge held by small groups is powerful, but fragile. Fire making, fuel selection, ember carrying, and cooking techniques all require teaching. If transmission breaks, a skill can weaken or disappear. The uneven evidence also challenges simple stories about intelligence. It is tempting to treat fire control as a bright line between advanced and primitive minds, but the record does not support such a clean division. Neanderthals used fire, yet their fire evidence is patchy in some contexts. Early Homo may have used fire in certain places long before it becomes clearly common across wider regions. Modern humans inherit fire as part of a larger cultural system, but even they must adapt it to local conditions. Intelligence does not automatically produce flame at all times. A clever group without dry tinder, without suitable minerals, without fuel, or without the learned method may still face a cold night. This is why disputed sites matter so much. Each old burned patch becomes more than a local find. It becomes a clue in a much larger argument about when fire became dependable. At one site, heated stone may suggest controlled use. At another, charcoal may be intrusive. At another, burned bones may come from wildfire. At another, microscopic ash deep inside a cave may strongly imply human activity. The debate can seem technical, but beneath it lies a major human question. Were early humans already living in a fire-shaped world hundreds of thousands of years earlier than once believed? Or were they still partly dependent on chance? The answer may differ by region, species, and environment. The mystery of uneven fire evidence also keeps the cooking debate open. If cooking was essential very early, archaeologists expect to find regular fire earlier and more widely. But if cooking became important gradually, or if other processing methods such as pounding, cutting, drying, and fermentation carried part of the burden first, then the patchy record makes more sense. Fire may have entered human diet in pulses, becoming crucial in some places before others. It may have been used first for protection, warmth, or food preservation, with cooking becoming increasingly central later. Scholars still debate these possibilities because the evidence remains incomplete, and because human evolution rarely gives one cause the whole stage. The contradiction, then, is not a weakness in the story. It is the story. Fire is essential in the long run, yet difficult in the beginning. It is powerful, yet dependent on fragile knowledge. It is transformative, yet sometimes invisible after burial. It spreads, but not evenly. It becomes human, but only through repeated acts of attention that the earth often fails to remember. The old hearths that survive are islands of light in a much darker archive. Between them are gaps, vanished camps, dead embers, lost techniques, burned meals, warm nights, cold failures, and generations whose fire left no trace. To follow the human past honestly, those gaps must remain visible. They prevent the story from becoming too smooth. They remind us that early humanity was not carried forward by inevitable progress, but by uncertain practice. A flame could be found and lost. A method could be learned and forgotten. A hearth could save a child one winter and leave no mark for archaeologists to find. The ancient world was full of fire, but the record preserves only scattered embers, and in those embers, the mystery remains alive, not whether fire mattered, but how long it took for a dangerous force of nature to become a dependable companion of human life. Once fire becomes dependable, it begins to escape the narrow category of tool. A hand axe is a tool, a spear is a tool, a scraper is a tool. Fire is stranger. It is an activity, a place, a danger, a process, a memory, and a relationship. It must be made or maintained, fed or starved, watched or abandoned. It changes the ground where people sit, the food they eat, the animals that approach, the hours they remain awake, and the materials they can reshape. It is useful in the obvious ways, but its deepest influence comes from repetition. Night after night, season after season, generation after generation, the hearth trains human life to gather around a center. That gathering is one of the quiet foundations of culture. A group can gather around food without fire, and social life is older than the hearth. But fire intensifies gathering. It creates a fixed point in a moving world. In a camp, the flame is not merely somewhere to warm hands. It is where attention returns. People bring fuel toward it, food toward it, tools toward it, bodies toward it, and eventually memories toward it. The hearth organizes space by use and meaning. There is the dangerous inner edge where sparks leap. There is the warmer ring where food is prepared. There is the smoky side and the clearer side. There are places where children are pulled back, where tools are repaired, where bones are discarded, where embers are banked for mourning. These arrangements may leave only stains and fragments, but they reflect something larger, a group learning to order its world. The fire also changes the emotional shape of place. A cave mouth, a lakeshore, a riverbank, or a windbreak becomes more than shelter once it has held flame repeatedly. It becomes familiar. The ground remembers ash. People remember where smoke moves when the wind comes from the north, where dry branches can be stacked, where sparks must be kept away from bedding, where predators were once seen at the edge of the light. This is how landscape becomes a lived landscape, not simply a terrain crossed by animals, but a network of places with histories attached to them. A hearth can turn a temporary camp into a remembered site, and remembered sites are the early architecture of belonging. Fire's role in symbolic life is harder to prove, but difficult to ignore. Flame attracts the eye. It moves without walking, speaks without voice, consumes without a mouth, and turns solid wood into light, heat, smoke, and ash. Ancient people did not need modern science to feel its strangeness, yet caution is necessary. No one can claim to know the first spiritual meaning of fire, or whether early humans saw it as alive, sacred, dangerous, ordinary, or all of these at once. The evidence remains incomplete, but later human cultures across the world repeatedly attach meaning to flame, purification, danger, transformation, death, renewal, home, offering, warning, and memory. These later meanings cannot simply be projected backward into the deep past, yet they show how naturally fire lends itself to thought beyond utility. A force that changes everything it touches almost invites metaphor. The cave deepens this connection. Without fire or portable light, the inner darkness of caves is nearly inaccessible to sustained human activity. Later prehistoric people carry lamps, torches, and embers into underground spaces, leaving soot, charcoal marks, footprints, pigments, and art in places where sunlight never reaches. The great painted caves belong much later than the earliest fire use, and they should not be treated as direct evidence for the minds of much older humans. Still, they reveal an important possibility created by flame. Fire allows humans to enter darkness deliberately, not merely endure it. It turns hidden chambers into places of image, sound, movement, and meaning. This same technology that keeps predators away at a camp edge eventually lights walls where animals appear in mineral color. The path from hearth to painted cave is not straight, but it is illuminated by the same principle. Fire extends human presence into spaces the unaided body could not easily claim. Pigment and heat also meet in subtle ways. Ochre and other mineral colors appear in human and pre-human contexts, sometimes used on bodies, objects, or surfaces, though interpretation remains debated. Heating can alter some pigments, changing color or texture. Later people learn to control these transformations more deliberately. Whether every heated pigment in ancient context reflects symbolic intention is uncertain, and scholars still debate the meanings of early color use. But the broader pattern fits the growing fire world. Heat reveals hidden properties in matter. A mineral can change color. A resin can become adhesive. A hide can become more durable. A food can become safer. A place can become habitable. A dark wall can become visible. Culture grows in part from noticing such transformations and repeating them until they become tradition. Fire also begins to change the relationship between humans and other species. Around a camp, some animals retreat while others are drawn in. Predators may avoid flame, but scavengers may investigate discarded bones after people leave. Insects may be repelled by smoke. Small animals may be flushed from burned patches. Later, as humans learn to burn landscapes more deliberately, fire becomes an ecological force guided by intention. It can encourage fresh plant growth, open travel routes, concentrate game, reduce underbrush, and reshape the balance between woodland and grassland. For very ancient periods, deliberate landscape management is difficult to prove and must not be overstated. Natural fires were already major ecological agents long before humans. Yet in later prehistory, and among many traditional societies, controlled burning becomes a sophisticated form of environmental knowledge. It suggests what the long relationship with flame eventually makes possible. Humans do not only adapt to ecosystems, they begin to participate in directing them. This participation carries responsibility before anyone names it as such. A controlled burn can renew a landscape, but an uncontrolled one can destroy shelter, drive away animals, consume fuel, or trap the unwary. A hearth can cook food, but it can also burn a child. Smoke can protect against insects, but it can damage lungs. The same fire that preserves meat can ruin it. The same flame that draws a group together can expose its location to rivals. Culture develops not around fire's goodness, but around its ambivalence. To live with fire is to learn limits. Too close and it harms. Too far and it fails. Too much and it devours. Too little and darkness returns. The hearth may have shaped ideas of home long before permanent houses existed. A mobile group can carry tools, ornaments, memories, and kinship. But a lit fire makes a stopping place feel occupied in a special way. The warmth, smell, smoke, and light mark human presence. Even after the group leaves, ash remains as a trace of having been there. Later, agricultural villages will build houses around fixed hearths. Later cities will hide fire in ovens, kilns, lamps, workshops, and furnaces. But the emotional root is older. A human place is a place where heat has been guarded against the dark. By now, fire has become more than survival. It has become a way of making worlds. It turns raw food into shared meals, dark hours into social time, caves into shelters and later sanctuaries, minerals into color, bark into adhesive, landscapes into managed mosaics, and temporary camps into remembered places. It does not create culture alone, but it gives culture a center that can be seen, felt, smelled, and tended. The flame is never merely possessed, it is practiced. It must be renewed by each generation, and in that renewal people learn not only how to stay alive, but how to live together inside a circle of meaning. Beyond the fire, the old night remains. Inside it, the human world grows denser, warmer, stranger, and more deeply marked by the power to transform. The legacy of fire is not preserved only in ancient ash. It is written into the modern human body, into the arrangement of meals, into the expectation of warmth, into the shape of kitchens, lamps, engines, and cities, and into the quiet fact that most people alive today would find a fully raw, fireless life almost unimaginable. The flame that once had to be guarded through rain and darkness now hides in wires, gas lines, power plants, furnaces, satellites, and the chemistry of cooked food served without thought. It has become so ordinary that its strangeness disappears. Yet every cooked meal still carries a trace of the old transformation outside heat doing work that teeth, jaws, stomachs, and microbes would otherwise have to do alone. The human body remains a kind of fossil of this partnership. Small jaws, reduced chewing muscles, relatively delicate teeth, long childhoods, large energy-hungry brains, and dependence on processed food, all speak to a lineage that did not adapt by biology alone. Humans became creatures of technique. They did not wait for evolution to build larger claws, thicker fur, stronger jaws, or night vision equal to predators. They made tools, shared knowledge, carried memory, and learned to place food into heat. This does not mean fire single-handedly created humanity. The evidence remains incomplete, and scholars still debate how much weight to give cooking, meat-eating, plant processing, fermentation, social learning, climate instability, and cooperation. But the deep pattern is difficult to ignore. Human evolution is not only the story of bodies changing inside nature, it is the story of bodies changing because culture begins to alter the conditions under which bodies live. Neanderthals and Denisovans widen that legacy. They remind us that fire was not the private inheritance of modern humans alone. Neanderthals warmed themselves, cooked, made adhesives, occupied shelters, and faced Ice Age landscapes with a knowledge of flame shaped by hundreds of thousands of years. Denisovans remain more hidden, but their world too almost certainly included fire in caves, cold regions, highlands, and corridors across Asia, even if the exact hearths cannot always be assigned to them with certainty. These relatives are gone as distinct populations, but not entirely gone from the human story. Neanderthal and Denisovan DNA survives in many living people, carrying immune, metabolic, skin, altitude, and other adaptations that modern science is still trying to understand. Their bodies vanished as separate peoples, yet fragments of their inheritance remain inside the wider human family. Fire belongs to that same braided inheritance. It crosses species boundaries, geographic boundaries, and cultural boundaries. It is present in the lives of early Homo, Neanderthals, Denisovans, and modern humans, though not always in the same ways or with the same reliability. Around its glow, different kinds of humans cook, repair, teach, endure cold, watch darkness, and make temporary homes. The old idea of a single ladder of progress cannot hold this complexity. Human evolution looks more like a network of embers, some bright, some dying, some carried onward, some lost, some merging with others when groups meet and interbreed. The mystery is that something so central can remain so partial in the record. Fire helped shape survival, but many of its traces are gone. Meals vanish, smoke disperses, wood becomes ash, ash dissolves, voices fade, No one can recover the first time a child learned not to touch a coal, the first time an elder banked embers successfully through rain, the first time fish was placed near heat and came away softer, the first time a group realized the night could be held back. Archaeology gives fragments, not whole lives, yet the fragments are enough to show that flame changed the terms of existence. It gave humans a way to borrow power from the physical world and carry it into the fragile circle of social life. That power eventually grows far beyond the hearth. Fire leads, over immense time, towards ceramics, metallurgy, glass, agriculture, industry, combustion engines, electricity, rockets, and the modern planetary footprint of humanity. The same basic principle remains: matter can be transformed through controlled energy. But the story also carries warning. Fire is never only gift. It consumes forests, homes, bodies, fuel, and eventually entire atmospheres when multiplied through industry. The force that helped humans survive cold nights has also helped create a warming world. This does not erase its ancient importance. It makes the inheritance heavier. Humanity's first great energy technology still asks the same question it asked at the hearth. Can this power be tended without being allowed to devour what sustains it? In the end, fire made humans human not by replacing nature, but by changing the conversation with it. It allowed a weakly clawed, thin-skinned, long childhood primate to sleep in darker places, eat tougher foods, cross colder lands, gather after sunset, and build memory into shared practice. It helped feed the brain, but also gathered the social world in which that brain mattered. It made the body softer in some ways and culture stronger in others. It turned survival into a learned art. The ancient flame is therefore not behind us in any simple sense. It is still present wherever food is cooked, wherever light pushes back dark, wherever people gather around warmth, and wherever transformation begins with the careful control of heat. The embers burn lower now, and the story widens beyond one cave, one lakeshore, one species, or one night. The first fire watchers are gone beyond naming. Their shelters have collapsed, their tools have scattered, their footprints have filled with sediment, and the wood they carried has long since become ash, soil, or nothing at all. Yet something of them remains in the ordinary human gesture of drawing close to warmth, in the patience of waiting for food to soften, in the comfort of light when darkness gathers outside. Time is merciless with details. It removes faces first, then voices, then names, then most of the places where lives unfolded. It leaves a burned stone, a tooth, a fragment of charcoal, a faint stain in earth, a bone altered by heat. From these small survivals, a larger image returns humans and human relatives gathered against cold, hunger, and fear, not as masters of the planet, but as careful learners beside a dangerous glow. Fire did not make life safe. Nothing in deep history was safe for long. Storms came, embers died, children were lost, groups vanished, Neanderthals disappeared as a people, Denisovans faded into fragments of DNA and a few hard pieces of bone. Even Homo sapiens, the survivor, carried forward not certainty, but memory, technique, and dependence. The flame that protected also demanded care. It had to be watched, fed, and respected. Too little attention, and darkness returned. Too much confidence, and the fire escaped. Perhaps that is why the ancient hearth remains such a powerful image. It is small against the night, yet it changes everything close to it. It does not conquer the dark horizon. It simply creates a place where hands can work, where food can be shared, where children can see faces, where the old can remain warm, where fear becomes something held together rather than endured alone. Long before history, before cities, before writing, before any human knew the shape of the planet, there is this circle of light. Beyond it, animals move through reeds and trees. Above it, sparks rise briefly and disappear into a sky without names. Around it, the human story continues, fragile and bright, carried from one generation to the next like an ember sheltered carefully from the wind.